Good morning from Mission Control Houston. Thanks for waking up early for this momentous occasion as we bring you live coverage now of the expansion of the first ever human-rated expandable structure to be flown into space. Just right now on board the International Space Station, the steps begin expanding the Bigelow Expandable Activity Module, a partnership between Bigelow Aerospace and NASA to fly the first ever human-rated module to the International Space Station for an important technology demonstration. As we begin our show right now on board, NASA astronaut Jeff Williams kicking off the deployment sequence with the beam deployment controller. We're going to be following along over the next several minutes, hour or so throughout all of these dynamic activities. And we're going to be following about basically 5 major events with the expansion of this module.
I got AVV success, Fox.
Houston copies.
And again, as we are joining this operation right as it's beginning, Jeff Williams going to be going through a number of steps just now. There are 3 steps right off the bat with the deployment controller.
Houston copies and concurs. Stand by, Jeff.
And throughout this operation today, you're going to be hearing NASA astronaut Jeff Williams speaking with NASA astronaut Jessica Meir. She's just there at the bottom of your screen. Just next to her is NASA Flight Director Brian Smith, who's going to be leading the team down here on the ground through all the operations today. And again, we are joining just as these operations are beginning. Jeff Williams inside of the Tranquility node, to which the Bigelow Expandable Activity Module, or BEAM, as we're going to refer to it throughout the broadcast today.
1.701 is in work.
Houston copies.
And so again, the first step of our operation has already been initiated, that beam deployment controller kicking off the first 3 steps, the first of which was the closure of what are known as ascent vent valves. You'll hear them referred to as AVVs, and these are valves that have been open since the module launched in the trunk of Dragon and need to be closed in order for beam to hold the pressure that will soon be introduced when the air starts flowing into the expandable module. And we got confirmation that that first step did go successfully. The second step is the cutting of restraint straps that are around beam itself, and we're there just to ensure that it's in its pack configuration from launch all the way through installation, which it's been installed since mid-April. And with that, there was a known chance of the pyros holding those straps in place could not fire, or they could fire and the controller may have gotten a false negative. So Jeff Williams now going through steps to basically use tools on board to just make sure that those pyros did fire successfully and those restraint straps were released. And again, you'll be hearing calls consistently between him and Capcom Jessica Meir throughout all of our operations today. And then once we get confirmation that those straps were detached successfully, step number 3 will kick in, and that will be the release of the forward bulkhead from the aft bulkhead. Basically, there are 4 struts connecting the 2 together that have been taking all of the launch loads, all of the loads on the module itself from launch all the way through installation and where we sit now. And then a number of bolts on each of those sides will need to be released, and then the expansion will be able to begin. And then the physical expansion itself will be done again by Williams, actually manually inflating this module using first air from the International Space Station itself. And he's going to be opening up a valve for intermittent intervals, so anywhere from a couple of seconds to 30 seconds to even a minute at a time, depending on the feedback that he gets from the ground. And now initially these small inflation bursts will be very short, only several seconds in time as the module begins its initial expansion. And then Jeff will call down after taking pressure readings, feeding those values to the teams down here on the ground with the flight controllers at the ethos console and the flight controller at the robotics console, taking those values, feeding them into what's known as a pressure curve plot, basically a plot where using all of those values they can then calculate how long the next inflation period should be, and then Capcom Jeskamir will call up to Williams and instruct him just how long to inflate again and or introduce additional air. And again, this process could take up to 45 minutes or more. It needs to be done with constant video communication, as there will be an overlay that will be able to show you where beam will need to expand out, increasing its length by 68 inches. And you'll see a number of lines on that grid once we get that video communication back. And expected to inflate out to 68 inches, as far as 73 to get to its final length. Again, that packed length right now, 85 inches, will ultimately expand out to 158, and beam, once the full expansion complete, going from a volume of 127 cubic feet all the way out to 565 cubic feet. So a very big step up in size for this module from its packed configuration to that full expansion. And again, that expansion will be completed once the module has expanded out to that size, and they can confirm that the series of stabilization struts inside basically have locked into place, and the module will be able to hold its shape. At the actual expansion, the pressure inside of beam will only be about 0.4 psi, so not very much pressure required for the module to actually get its expanded shape and to hold that shape as well. And then following that, the pressurization of the module itself will begin. And that will be done by a series of air tanks, 8 air tanks inside of the module, and those will release air inside, pressurizing it up to the same atmospheric pressure as the rest of the International Space Station. And they can again introduce air from the station itself into beam, just in case the air in the tanks isn't quite enough to get it up to that 14.7 psi. The same atmospheric pressure that we have at sea level here on planet Earth is the same they enjoy inside of the cabin on the International Space Station. And then once that pressurization is complete, deployment will be finished, and the crew will begin another series of checks on the module itself and the vestibule in between it. That's just the small space in between the hatches on beam itself and the Tranquility node to which it's been attached for the last month and a half. And then all of that ultimately setting up for the first time the crew members will be able to go inside of beam. That's currently scheduled for June 2nd. And again, right now, Jeff Williams going through some optional procedures that were already timelined out by the crew just to make sure that these pyros, you may hear them referred to as NSIs, which is NASA Standard Initiator, basically just a pyro that can be fired and then release those restraint straps, which have been in place since beam launched inside of the trunk of a SpaceX Dragon. And so we'll continue to stand by and follow along with those procedures. Should get video communication back with the International Space Station any moment now, and we'll be able to ultimately watch beam as it expands. And again, we'll show you that grid.
To the other multimeter kit. All we have is a multimeter here. We don't have the accessories required.
Okay, stand by, Jeff.
And Capcom shortly going to tell Jeff Williams where to find all those items.
In the vacuum access jumper bag, 1.0 CTB 1256.
Okay, I'll look again.
And again, NASA astronaut Jeff Williams going to be basically at the controls, hands-on for all of this expansion activity this morning. While we wait for a lot of this to resume, just to continue to dive in a little bit more in depth on Beam, a very important technology demonstration taking place on board the International Space Station. An example of expandable habitat, something that can be much lower mass and packed much smaller, taking up less volume for launches than traditional metallic habitats, which comprise the entirety until Beam of the International Space Station, being looked at as an important technology that could be used on very long duration missions of the future. As we continue to look to head out to Mars, there are a number of challenges that NASA and all of the other interested parties are continuing to work to try and solve. And then before we ever send the first astronauts, several rockets will launch with cargo, supplies, and then deploy to await crew's arrivals. These expandable modules, which are lower mass again and take up less volume on a rocket, could increase the efficiency of these cargo shipments and then reduce the number of launches. And then expandables also being looked at as potential concepts for habitation capability in cislunar space, the area between Earth and the Moon, with applicability and in-space transit habitation.
The test adapters, and we have the wires, and we have what we think will work to measure across these pins.
Okay, we copy.
So again, right now, Jeff Williams inside of the Tranquility module. We're going to see him in there throughout the operation today. Beam currently attached to the aft port on the module. It's the same one that has the cupola attached and also the permanent multi-purpose module, the large storage section on board the station, also the crew's exercise equipment and one of two station toilets on board. And again, right now we're in this step where Williams is going to be manually measuring whether or not these pyros successfully fired. This is step 2 in the 5-step process of expansion today. And again, step 1 done successfully, closing those ascent vent valves. Those were valves that were opened or were left open during all of the ascent to orbit. Beam kept at a vacuum, so no pressure inside. These valves now closed, enabling the module to hold pressure. They'll get an extra layer of redundancy when the crew will install caps once they go in for the very first time. Again, that first ingress, as we'll call it, scheduled to take place on Thursday, June 2nd. And once this step is completed and Williams is able to confirm that those restraint straps were cut, they can then reinitiate the controller. Every time they run it, it'll go through all of the different steps over again. So it'll once again confirm that those valves are closed and then the restraint straps were cut. And then step 3 will initiate, and that'll be the release of the bulkhead.
Yeah, Jeff, the pin kit is in PMM. That's the 1.0 CTB serial number 1096. So that's PMM 1, overhead 2, Delta 1.
And there are 2 pin kits in that CTB. Can you specify which ones we need?
Either one should work, Jeff.
And we'll have several views of beam itself once it expands. One of the best ones coming from just in the tip of the robotic arm, Canadarm2, which was used to install the expandable module back in April. We'll also be able to show you an overlay, a robotic overlay, showing a grid of just how far beam is expanding. This being used by the robotics officer here in Houston.
And Jeff, just a heads up, you should first try the 16 gauge as specified, but if that's not a good fit, you can use the 20 gauge.
Copy.
And again, that overlay view showing a grid of just how far beam will be expanding. First, lengthwise, we'll be looking to expand it out 68 inches at least beyond its current packed configuration of 85 inches in length. Ultimately, once everything is expanded and pressurized, beam should be 158 inches in length. And again, you'll also see it expand across its diameter, going from 93 inches to 127 inches in diameter. One of the interesting aspects of this expansion is there are a number of expansion scenarios, so a number of shapes that beam could ultimately take during this initial expansion period when Williams is manually flowing air into beam from the station itself. But again, right now, Williams on board working through step 2 again. This already on the timeline just in case this step had this issue, so he'll work through to get some manual readings to make sure that those pyros are firing successfully. Then we'll be able to kick off the expansion procedures once more and then eventually set up for that manual inflation. It was originally targeted to begin at about 5:10 a.m. Central Time, so still right on the timeline, and should be plenty of daylight. The station actually in what's known as a high beta angle, so almost near constant sunlight for several orbits today. There should be just a short sunset and sunrise coming up, but for the most part, the station going to be in almost constant sunlight. So plenty of light for the teams on the ground to monitor beam's expansion, which was a requirement, and also plenty of video communication with the station through our tracking and data relay satellites, allowing them to track from down on the ground. And again, this manual inflation process will be a tandem effort with Williams taking consistent pressure readings after each introduction of air into the beam module, and then that will be fed to the flight controllers down here on the ground, who will feed that into a plot and then radio back up the length of the next introduction of air. Again, Capcom, Jess Camille are going to be chatting very frequently, relaying a lot of instructions to Williams as he works inside of the Tranquility module on this manual inflation this morning.
In Houston, for NSI-1, I show a value of 5.68.
Copy, Jeff. And Jeff, could you confirm your units, please? I think we see mega ohms.
I've got it in the ohms position, and I do read an M before the ohm sign.
Okay, copy.
And again, there were 3 pyros set to fire. You'll hear them referred to as NSIs, which stands for NASA Standard Initiator. And again, those 3 pyros were meant to cut the restraint straps holding beam in its packed configuration. Step 2 of 5 for our operations this morning. right now, Jeff Williams using a multimeter to just get manual readings on whether or not those pyros fired. And then once they confirm all of those values line up, they'll begin to or be able to continue the expansion process. And so this process could take up to about 30 minutes, getting us then back into the flow of procedures and then onto that manual inflation step where beam will start to take shape.
3.84 currently.
And Jeff, if you don't mind confirming the units with each measurement since the multimeter is in auto range.
3.85 mega ohms.
Houston copies.
NSI 3 is 0.729 kilo ohms.
Houston copies.
And Williams continuing to take these multimeter readings on those NSIs, again, those pyros that were meant to fire to release the restraint straps that were in place.
310.8 ohms.
Houston copies.
NSI 5 reads 94.4 ohms.
Houston copies.
NSI 6 is 146.3 ohms.
Houston copies.
With your concurrence, I'll go back and remeasure NSI number 5 just to confirm.
Houston copies.
And repeating NSI 5, it reads 94.7 ohms.
We copy.
And so at this point, all 6 NSIs, or those pyros, have been measured. There's 2 per strap. Again, there's 3 straps in total. So the team's now looking at all of the readings that Williams was able to take, and then we'll soon be relaying instructions on where we are now in our procedures, whether we're ready to proceed with the expansion.
Okay, Jeff, good news. Those values confirm that all 3 straps have been cut, so you can continue in step 2.7.
Copy, we're continuing.
And so Jessica Meir delivering the good news.
For your essay, we can verify that we have good cutting on all 3 straps because we did have redundancy in those pyros. So both values 4 and 5 are for the same strap. So since 4 passed and was greater than 100 ohms, we know that we're okay and all straps are cut.
Okay, very good. Thank you.
And again, Williams getting the call. There were 2 pyros per strap, 3 restraint straps in total holding beam in that packed configuration, and that multimeter confirming that all 3 straps have been cut, so step 2 was done successfully. And at this point, we'll be able to pick up on our procedures, kicking off again with the deployment controller. Again, those ascent vent valves already successfully closed and now confirm the restraint straps have been cut. Next up will be the release of the forward bulkhead. So there are 4 struts connecting the forward and the aft bulkheads, basically the 2 big ends of on beam. And those will need to be released so the actual expansion can take place, as these bulkheads holding, or these struts holding the 2 bulkheads together are there. They've been taking all of the launch loads essentially and holding them together. There are 4 bolts holding these struts together, and each of them needing to release. Each one will talk to the controller. These can also be done manually, again, if any hiccups come from the controller, but that'll be the next step. And then after that, the manual inflation of beam, and it will begin to take its final shape.
So I'm looking to see where I go next.
We copy, Jeff. Stand by. And Jeff, with that, you have a go to pick up on the next timelined activity, and that's again the deployment controller. So it's 3.5, step 3.5 of 1.302.
And with that, Jeff Williams getting the go to proceed, go back to where they were on the timeline and begin or resume the deployment procedures.
3.5 of 1.302.
Affirm.
And once the forward bulkhead gets released, the manual inflation of beam will begin. And that expected to take up to 45 minutes. Again, it'll be a very incremental process of Williams gradually introducing air from the station itself through a valve into the expandable module. Williams will open the valve for just a few seconds at a time, especially to begin with, and then close it, take a pressure reading, and call that down to the flight control team here in Houston. After that, the ethos position and the robotics officer will take the data and compare it, and then give Capcom a number that will be radioed up to Williams for how long he should then open the valve again, and it will just be this repeating process until Beam has expanded out to its length, to a length of an additional 68 inches, bringing it just a few inches short of its anticipated final length of 158.
Houston copies. Okay, Jeff, you have a go for the next activity again. That is Table 1 and 1.303.
Copy, reinitiating Table 1 and 1.303. I got AVV sequencing.
Houston copies.
Again, the Beam deployment controller now running again through those first 3 steps. The SN vent valves already confirmed to have closed, those 2 redundant valves that needed to be closed in order for Beam to keep pressure. There, the message again, the AVV success. Next on to, again, confirming the restraint straps.
We copy.
RSC success, Fox.
Houston copies and concurs.
And this time getting that success on those restraint straps.
And I got an audible.
We copy.
FBH success, Fox. ISV sequencing.
Houston copies.
And step 3 complete. And with that, the first 3 automated steps from the deployment controller completed. Next up is going to be that manual inflation. We'll start to see Beam take shape. And they'll wait just a few moments until Videocom comes back with the station, because again, the teams down here on the ground needing to follow along on that plot just to make sure that they're aware of just how far along in the expansion beam is, as they'll be feeding up the times, the amount of time that Williams needs to hold that valve open to introduce air from the station itself over to Beam. Again, this is step 4 or 5 in the overall deployment for today. The first 3 now done successfully, and so now step 4 kicks in. This is expected to take about 45 minutes or so, and will expand Beam out to its...
And you can pick up in 4.2.1.
Will expand Beam out to its final shape. And again, this view from the camera right on the tip of the Canadarm2 robotic arm going to be probably our best view of the expansion.
That's still in table 1 of 1.303. You do not need to wait for the sequence to complete, so you can pick up with 4.2.1.
Okay, I understand that's 4.2.
Yeah, Jeff, so in table 1, you were in 4.2, and now you can see the ISV sequencing. You do not need to wait for that, so you can continue to 4.2.2.
Okay, got it.
And so Williams powering down the deployment controller for now. And it'll get powered back up once it's time to pressurize beam following this manual inflation activity. And as you can see, the sun's starting to set. It'll only be set for a couple of minutes on the station, but they'll probably wait until the end of this pass.
Stand by, Jeff. We're coming up on eclipse, so we're going to have to hold for that. Our estimated time to pick back up will be 10:10.
Copy.
And again, daylight being a requirement for this expansion operation, so they'll stand by just for the next 3 minutes or so, 10:10 GMT, 5:10 a.m. Houston time, so right on the timeline for when the expansion was expected to take place. And again, the station in a high beta angle, so basically in a state of almost constant sunlight. Following this eclipse will be several orbits around the Earth, potentially with no sunset for the station, so plenty of sunlight for the rest of the operations. Also plenty of both voice and video comms, so we should have an unbroken streak of operations following this next sunset. So we should be back in about 2 minutes with full sunlight, and then the expansion will resume. And again, we're in step 4, the manual inflation of beam, with Williams manually introducing air from the station itself into beam. And once that's finished, the internal pressure of beam will only be at about 0.4 psi, but still able to hold that initial shape, as it will be in a vacuum, so no pressure pushing in on it from the outside. And all of that will set up for the ultimate pressurization up to cabin pressure with the rest of the International Space Station.
The actual dynamics of the beam module. If you could give us a heads up prior to the appropriate steps of what we might expect visually, that would be helpful, I think, for the entire crew.
Okay, Jeff, copy. We will do that for you.
So again, just standing by a couple of minutes until the sun fully back up. And good daylight for the teams down here on the ground to follow along with the manual expansion of beam. And all of this setting up, of course, for the first time that the crew will go inside this, the first human-rated expandable module built by Bigelow Aerospace and flown on a SpaceX Dragon and installed on the International Space Station. The crew scheduled to go in for the first time on June 2nd, so just about a week from now. and the crew ultimately going to be responsible for installing a number of sensors, but of course all of that done a week from now after the expansion and leak checks completed.
4.6 and then subsequent steps in 4.9 as we cycle through. We're not sure how many iterations that we'll need to get to our full volume, but we'll be going through that a few times.
Okay, I understand. Yeah, I was trying to remember. I thought that there was enough potential energy that was going to be released that we would get deployment before pressurization, but apparently that's not the case.
Right. With the manual inflation, we will get to a larger value, and then we'll go to the final pressurization, which will again increase it slightly.
Okay.
Capcoms, go.
Flipped.
Okay, Jeff, we are go for manual inflation. You can pick back up in step 4. And that'll be for you, step 4.2.
Okay, 4.2 is complete, and the ISS crew is ready for beam inflation.
And so with that, the manual expansion of beam now set to begin. Jeff Williams going to be slowly introducing air from the station itself into the Bigelow expandable activity module.
4.4 through 4.6.
Copy, initiating inflation.
And again, this is going to be done in a very incremental process. That first introduction of air only being for about 5 seconds. And then throughout this process, Williams is going to be taking pressure readings and then feeding those back down to the teams here in Mission Control Houston, who will then come up with the next amount of time that he needs to introduce air into beam, and this process just done incrementally over time until the module again expands out an additional at least 68 inches as far as 73, which will be its final length of 158 inches.
For 4.5, I do read 8.1.
We copy. Please stand by, Jeff.
Standing by. I currently read 14.0.
Copy. And Jeff, please hold here for a moment.
Holding.
And Jeff, did you complete 4.6 as well?
Affirmative.
Copy.
And so Williams beginning the deployment process. He's opened the valve for just a couple of seconds. If we look at the grid, we can see that beam has moved just very slightly past that initial line. Again, this is going to be a very incremental process to expand it out all of the way, taking about 45 minutes.
5 seconds each time.
Copy. 2 times, 5 seconds each. Okay, Jeff, that puts us at 4.7, which is a ground step, so stand by.
Goodbye.
So now the team's here in mission control looking at the data that's been sent down, the pressure reading sent down by Jeff Williams, and they'll feed that into what's known as their pressure curve plot. And then Ethos and the robotics officer will work together to convert how long Williams then next will need to open up the valve to introduce an additional amount of air into beam. And that'll be relayed to Capcom, which will go up to Jeff, and then we'll just recycle that process over and over until beam is fully expanded. So it'll be this iterative process where we'll stand by for a couple of moments down here on the ground while they do their calculations, and then Williams will again open up the valve and begin this expansion. Again, the module did jump ever so slightly out to a maybe an inch or so beyond its original point, so the expansion has begun. It'll be a slow process, but expanding out a total of 68 inches or more, all the way out to 73 inches by the time this is all completed today. And this is a view again inside of the Tranquility module at the hatchway.
We have seen some expansion of beam, and we're assessing right now.
Copy. Standing by.
This is a view again of that hatchway to beam, which will be opened up a week from now following a successful expansion. And the first ingress, the first time the crew will go inside, will be a week from now on June 2nd. No lights inside of beam, so the crew will use battery operated flashlights to go inside when they set up all of the sensors, which will be their primary purpose for that first ingress. And these sensors over the next 2 years will be measuring radiation exposure as well as temperature changes to the external and internal structure of beam, and also monitoring for any MMOD, micrometeoroid, or orbital debris impacts to see how the module holds up. Again, rated to the exact same specifications that we have rated all of the metallic modules, and beam itself actually placed in a part of station, also smaller when compared to the other station modules, that significantly reduces the risk from MMOD to beam.
So Jeff, while we're assessing, just to repeat that big picture, we're going to be going through a series of iterations, opening and closing that sampling port. So each time we'll be providing you the value of how long, and then we'll be asking you for that pressure reading.
Okay, I understand.
Okay, Jeff, you can now pick up in step 4.9. The first iteration for the ISS sampling port will be a duration of 4 seconds. That's 4 seconds.
Copy, 4 seconds. Four seconds complete. The valve is now closed. Pressure 17.1.
Houston copies. And Jeff, keep an eye on the pressure and let us know if it stays stable there or if it continues to increase.
Currently the pressure is 17.0.
We copy.
And so another quick burst of air into beam. The robotics officer reporting that first bit of expansion, 3 inches in length, 5 in diameter. All of this kicking off right at around 5:10 a.m. Central Time, 6:10 a.m. Eastern per the timeline. Williams just completing another opening of the valve, this time for 4 seconds, and the teams will once again do their calculations and get him a time for the next opening. Again, as we continue to see beams slowly expand over the next 30 to 40 minutes or so. And this step 4 of 5 in today's procedures, once beams all the way expanded to at least that additional 68 inches, we'll be able to move into the pressurization where the 8 air tanks, which are inside of the expandable module, will be opened, releasing air to pressurize the module up to that atmospheric pressure that the station itself is in. It takes about 42 pounds of air to bring beam up to its full pressurization, and that can come from those tanks. It could also come additionally from the station itself, but that expected to be the final step today. And again, we'll continue to get a couple of external views from the robotic arm and the cameras on the station structure itself as beam will slowly creep out and expand to this full size. Again, going from an internal volume of 127 cubic feet to 565 cubic feet during the operations today. So a very significant increase in size.
And Houston, just to add to your essay, on the second inflation of 5 seconds, I did hear a very distinct audible sound from the other side of the hatch, something given loose.
Houston copies.
And so Videocom coming back shortly, should get the next call for the next introduction of air shortly.
Okay, Jeff, we're ready for that second iteration, so that sends you back to 4.9. This time, open only for 1 second. 1 second.
1 second, 4.9 and work. The valve is closed. Pressure is 17.4. It was 16.8.
Houston copies.
And as we continue to stand by for the next step to continue expanding beam, just a couple of cool facts about the module itself. Again, it's going to ultimately expand out to a internal volume of 565 cubic feet, weighing in at 1,415 kilograms in total. The air inside of the module itself, once it's fully expanded and pressurized, will actually recycle fairly quickly. The air going to be turning over every 39 minutes, or about 3,000 times a month inside of beam. And there won't be any hardware or storage inside of the module itself. Instead, there will be a series of sensors that will be placed throughout to measure dynamic loads and radiation and temperature and other important data that will be fed into a laptop that's downlinked down to the ground for the engineers to continually review over the next 2 years.
Jeff, could you give us another pressure reading, please?
17.3.
Copy.
So getting a report, the diameter of beam expanding another 2 inches, 0 in length this pass. Again, the exact shape that beam will take throughout this process is unknown. There are a number of expansion scenarios.
Jeff, you have a go for 1 second. One more time. 1 second.
Copy, 1 second.
Williams getting the call for another 1 second burst of air into beam.
Pressure's 17.2.
Copy.
Valve is closed. Ending pressure 18.2.
Copy.
And again, that grid overlay that the robotics officer here in Houston using to measure just how much beam is expanding each time we introduce a little bit more air into the module. And that being used with the pressure readings to then determine the next length of time that Williams will be opening that valve to put more air from the station into beam itself. Beam an important technology demonstration, one of many taking place on board the International Space Station, this one with some direct applicability to future long-duration missions, future habitats for areas around the moon or even onto Mars. NASA partnering with a number of companies in the commercial industry on the development of advanced exploration systems such as habitation. Bigelow Aerospace, actually one of 4 commercial companies working with NASA through the Next Space Technologies for Exploration Partnerships Next Step to provide conceptual studies for how habitats could be used for deep space requirements.
And Jeff, could you give us another pressure reading, please?
18.0.
Copy.
And hearing that last second burst, giving another 5 inches in length to beam 2 inches in diameter, so continuing to move along in the process, again very gradual to get it out to that additional 68 inches in length, ultimately all the way out to 158 inches once it's fully expanded. And again, for now, the team is assessing the pressure readings, comparing that to how much the module has expanded so far, both in length and in radius. And then following that, radioing up another length of time and more instructions for Williams.
And Jeff, just to give you a heads up, the reason why we're waiting here, we're slightly above our safe pressure curve, so we're waiting to see if we get a slightly lower reading before we can continue.
Okay, I understand.
So the team's just waiting for the pressure to settle a little bit before they give Williams the call again to begin reintroducing more air into beam. The engineering support team here in Mission Control Houston working in tandem with engineers from Bigelow Aerospace.
Affirm, Jeff. That's a good view. Thank you.
And again, just standing by here, the teams in Mission Control Houston looking over the data, making sure that everything lines up before they give Jeff Williams the go to continue this manual inflation of the Bigelow Expandable Activity Module. So again, just standing by a few more moments. The teams again waiting for the pressure in beam to settle out before they continue the gradual expansion process. This entire thing expected to take 45 minutes or more, as it is these very slow, very short, gradual introductions of air into the module from the station itself. Again, NASA astronaut Jeff Williams standing by inside the Tranquility module.
Jeff, thanks for your patience. We're still discussing our safe pressure curves.
Okay, thanks for the status.
And throughout the expansion process, the team's just needing to make sure that the pressure readings inside a beam are consistent with how much the module has expanded, both lengthwise and across the diameter.
And Jeff, the multimeter has timed out, so you can just power cycle it from off back to your setting there. Thank you.
And the team's here taking one more look at the data. Going to be getting a call up to Jeff Williams in the next minute or so. Again, in the room, Flight Director Brian Smith leading all of the folks down here on the ground who are working in tandem with the astronaut to expand beam today.
Okay, Jeff, you have a go to open the port for 1 more second.
Copy, 1 second.
And a generous 1 second.
Understand.
And so Williams getting the go to once more open the valve, introduce a little bit more air into beam. And the team's hopefully getting a little bit more expansion both along the length and the diameter.
From 17.7, the pressure is now 19.5.
Houston copies.
I had no audible indication on the other side.
Copy.
And with that additional second or generous second of air, the pressure now up to 19.5, and it'll settle over the next several minutes as again the robotics officer now analyzing any increases in the length and diameter of beam. And they'll once again compare that to their safe pressure curve plot, that plot that they're using to inform them on how much or how long the valve should be open to put more air into beam from station. So once more in that short holding pattern, hopefully. Hopefully the module expanding out a little bit more, and this process will eventually pick up beyond these 1 second introductions of air. But for now, we'll go ahead and stand by for a few moments while the teams here in Mission Control, again, mull over that data and then get some more info back up to Jeff Williams on board.
10 standby, Jeff. We're still assessing those safe pressure curves.
Copy, standing by.
The teams here in Mission Control and the mission evaluation room down in the MER, the engineering support teams looking again at all the data now and whether or not they'll be able to continue this expansion and how much time they'll give to Jeff Williams to introduce another burst of air into beam. And just a reminder, daylight and solid video communication required anytime this expansion gets the go, so the teams down here on the ground can monitor and calculate the values of expansion both in the radius and the length of, or the diameter and the length of the module as this expansion process takes place. Daylight not going to be a concern for the space station today. We will have video comm only for the next 10 to 15 minutes or so, and then there could be a gap and we'll have to pause. But for now, the operation continuing. Again, it kicked off at 5:10 a.m. Central Time with Williams opening the valve for the first time. And again, we're just continuing to stand by while the teams in mission control look over the data, the latest pressure readings, the increase in size that they're getting from that overlay from the robotic arm, and just looking over the data and what the next steps are going to be to continue with this expansion of beam today. And just to recap, the teams
and Jeff,
looking at the latest
again.
pressures.
So last time we were just close to the limit of the safe inflation curve, and now we're actually a little bit above, quite a bit more above it. So we are assessing where we are with the axial and radial displacement, and we're not exactly where we think we should be. So that's why we're talking things down here. Thanks for your patience.
Hey, Jessica, thanks for the status.
And that quick status from Capcom Jessica Mir. Again, just relaying the teams here, still looking at the data. They're a little bit above that safe pressure curve that they're using to plot out and then determine the amount of time Williams needs to open the valve for the inflation or the expansion of beam. And they're just going to continue to discuss for the next couple of minutes, come up with what their next steps are going to be, the next instructions up to Williams on board the station. The first 3 steps were done successfully earlier this morning with those ascent vent valves being closed, the restraint straps cut through pyros, and the forward bulkhead being released. And now we're in step 4 or 5. This manual inflation was originally expected to take about 45 minutes, going a little bit slower today as the expansion not going exactly according to some of the preliminary plans, but the team is looking at the data, seeing what they're able to do to continue this expansion process today. And then again, once beam fully expanded out following this initial inflation, the pressurization will be that final steps with the air tanks inside of beam opening up, and just to pressurize it to the same level as the rest of the International Space Station. Following that will be a series of leak checks, one long one, 80 hours in length over the weekend until the eventual first ingress, the first time the crew members will go inside of beam, currently slated to take place on Thursday, June 2nd. Continuing to stand by here from Mission Control Houston, the teams again assessing next steps, looking over the data a little bit above that safe pressure curve
So Jeff,
in
it's
terms
probably going to be about another 17 minutes since we're coming up on another pass here, 275 pass. So if you want to go take a look at that overlay, I can talk you through what we're looking at if you want to increase your SA there.
About the overlay that's being fed up to us on VC.
Okay, so if you're looking at it right now, basically, if you look at the grapple fixture where we're measuring for the axial displacement, it's where the pin meets the base plate. So right now we're at 5 inches, and we need to get to 68 inches to complete the manual inflation. And then for the diameter, we're currently at 96 inches, and we need to get to 127 inches.
Okay, understand. This is where those straps have to be overcome, right? Where they're going to snap the attenuation straps.
Yeah, Jeff, that's right. Those are those rip stitch straps, and there are a few different points, and we are getting close to the first point for that. Could you describe the noise that you said you heard earlier?
I don't know if I can describe it other than to just say it was a bang, and it was, as I recall, fairly distinct single bang. But my memory on its details are, I don't know if I can describe it in detail.
Okay, we copy.
And the team's continuing to talk
Jeff,
things
regarding
over
that
what they're...
we believe it was just the shear pins on the bulkhead, so that actually was as expected.
Okay, good to know. Thank you.
And that real quick, just an explanation of the noise that Williams had reported hearing, being a set of 4 pins that were expected to detach all at the same time, so that noise was expected. The engineering teams down here on the ground confirming. But again, the team's looking over all of the data, looking at next steps for this expansion process. We will lose video comm with the station momentarily, and there will be about a 17-minute gap until that good video signal locks back up. So there will be a pause in the operations. We'll just stand by for a little while until things resume here while the teams again continue to finalize their decisions, look over and determine what the next steps are going to be for this expansion. Again, it kicked off just about an hour ago at 5:10 a.m. Central Time. The first 3 steps of a 5-step process today being confirmed successful. And then Williams right now in step 4, this manual expansion of beam, slowly introducing air from the station into the expandable module itself. At a bit of a pause right now as they are above what's known as the safe pressure curve. It's a chart that they're using where they're comparing the pressure readings inside of the module to how much it is expanded out both lengthwise and diameter. And as we heard Capcom Jessica Meir explain, going from its packed length of 85 inches all the way out to 158 inches today. The diameter going from 93 all the way out to 127. And just a few inches so far on beam's expansion, so still very early on in the process. The team's looking at what their next steps, what options are available before they tag back up with NASA astronaut Jeff Williams, who's again being the hands, the eyes, and the ears for everything on board the station for this process today. And right now we are in that gap with the video communications, so operations for the expansion will pause for a little while. Should start to get signal back at about 6:21 Central Time, so in about 10 or 11 minutes, and it'll lock up solid at about 6:25 for another extended pass. And so we'll just continue to stand by while the teams discuss, and then we'll pick back up with today's operations to expand beam. Again, the first human-rated expandable module ever flown into space. Looking forward to getting it hopefully still expanded today. All that setting up for that first ingress, the first time the crew will go inside on June 2nd. So we'll just stand by for the next couple of minutes and then come back to you when operations resume. And for those of you just now tuning in to the expansion of Beam today, just giving you a quick update, we're in a holding pattern while we wait to acquire video back with the International Space Station, a requirement for all the expansion operations in the steps that we are currently in. The engineering teams here in Mission Control also still looking over the data, the pressure inside of Beam, and also how much it's expanded both across its length and diameter so far. They are a little bit above what's known as the safe pressure curve, so that plot that they're using to help determine how long Jeff Williams should then introduce air into Beam from station. And so looking at what the possible causes are and what any remediation available to them, what their next steps are going to be to see if we can continue along this expansion process, which kicked off a little over an hour ago at 5:10 a.m. Central Time, 6:10 a.m. Eastern. So just continuing to stand by. Again, we should lock up with good video comm in the next 10 minutes or so, and then hopefully get some words up to Jeff Williams on where we stand with this operation and what the next steps are going to be. So just continuing to stand by for just a little bit longer from here in Mission Control, hopefully getting back to Beam in the minutes to come. And getting that video comm back with the International Space Station. There might be a short handover in a minute or so, but should be locking up and hopefully getting back to the expansion operations in the not too distant future. This again a view from right down the end of the Canadarm2, the robotic arm that installed Beam back on April 16th, once it was removed from the trunk of SpaceX's 8th Dragon resupply mission, which brought it to the International Space Station unpressurized. And again, we're in step 4 of 5 today, the manual inflation of Beam, with Jeff Williams slowly passing air through a valve from station into Beam. We've been paused for several minutes while we waited for this video to come back, and also while the engineering teams here in Houston, both the NASA teams overseeing the station and teams from Bigelow Aerospace who are working with them down in the mission evaluation room, the MER, to decide next steps for this expansion process. The pressures that they're seeing inside the module a little bit higher than where we were expected to be in terms of how much it's physically expanded, both along the length and the diameter. So the team's again looking over that data, discussing all of the options and what the next steps will be to continue this expansion procedure.
And Jeff, if you could recycle that multimeter again, power cycle that one more time, that'd be great.
Go.
Continuing to stand by here in Mission Control Houston, Flight Director Brian Smith awaiting a report back from the MER, the engineering support teams from NASA and Bigelow Aerospace working together to determine next steps. And still continuing to stand by for that report from support engineers from NASA and Bigelow Aerospace on what the next steps are going to be. As you can see, though, we do have good sunlight and good video communication, so we could resume the expansion operations should the report come back favorable.
And Jeff, we are still assessing things down here, taking a look at those curves and at the axial and radial displacement. So still a bit of discussion going on in the back rooms, and that's why we're holding. If you like, you could look later in your timeline and grab an activity that you could put down or something short, maybe that CPA activity if you want to try to do something in between.
Okay, I'll go take a look at that. Thanks.
All right, we'll let you know when we're ready to pick back up.
the teams doing a quick video survey of those straps. Again, the restraint straps that were cut in step 2 of our operations today. The engineers from Bigelow Aerospace confirming that all 3 were cut successfully. So continuing to stand by until that report from the mission evaluation room, the support engineers from NASA and Bigelow Aerospace, again, looking at all of the data that's come down so far, the pressure readings, and just how far along the module has expanded both in length and diameter. Again, they have an expected plot with that's being called a pressure curve, where they have expected values for how far beam should be expanding both along its length and its diameter with a given pressure. And so they'll need to follow along with that. Right now, a little bit above the curve at the current stage, so looking at possible options, possible workarounds to continue this expansion procedure. But right now, Jeff Williams standing by on board the International Space Station. The team's here in Houston looking over all of the data and then hopefully coming up with the next steps in very soon. But for now, just continuing to stand by. Again, you can see still in the very early stages, just a couple of inches added so far, both length and diameter to beam from its packed configuration. A total of 68 inches needed to be added for the length for beam to be considered expanded and then be able to move on to that pressurization phase when the air tanks inside of the module will open up and do that final pressurization. But just going to stand by a few more moments. Again, plenty of sunlight, plenty of video communication with the station right now. So if the teams get the go, they'll be able to continue with this expansion operation. But for now, we're just going to continue to stand by for a few more minutes.
Station Houston on 2 for Tim Copra.
Go ahead on 2.
Yeah, Tim, we just wanted to give you an overview of everything that's going on here. We are at the point where we do think we can resume operations with Beam and begin to press further. However, as you guys know, we have this exercise constraint. So we wanted to make you guys all aware about that. You know, you're supposed to be starting your CVIS exercise now, so we need kind of a summary if you guys are okay delaying that for a while to see if we can resume with Beam.
We'll definitely delay so that we can resume with Beam. And I was looking at later in the day so we can both get our exercise in and meet the constraints for fundoscope. So if you guys can take a look at that for us and come up with a plan that allows us to be able to do Beam, fundoscope, and exercise, that would be great.
Okay, sounds good, Tim. We will look into that, and we're checking with the Russian crew about their exercise as well.
Okay, thank you.
And so as you just heard from the Capcom, getting close now to resuming the expansion operations with Beam. Again, the teams from Bigelow Aerospace and NASA evaluating all of the engineering data so far, coming to a conclusion that it's looking like we can resume the expansion operations. So Williams should hopefully be introducing some air into Beam soon.
Full. Do I need to change it out and initialize another card?
Stand by, Jeff.
And there is a constraint with the crew members exercising on the station while they expand Beam. And at this point in their timeline, all of the crew members, for the most part, or at least 4 of the 6 scheduled to begin exercise sessions. So the team's looking if they can delay that to a little bit later in the day.
Gig card and get that installed.
Good work. The barcode for the second card is 001888802 Juliet.
Houston copies.
And so Jeff Williams putting a new memory card into the camera as they are recording all of these, the operations that he's doing for the analysis teams down here on the ground. And then we should hopefully just be a few minutes now from resuming the expansion of Beam.
Station Houston on 2 for Tim Copra.
Go ahead on 2.
Yeah, Tim, if you want, you can get your CVIS in now. The CVIS constraint has been lifted, so CVIS is fine, and T2 is no-go, but CVIS is fine since that's on your time block now. You can get that started.
Okay, thanks, Jessica.
Okay, thank you.
Station on 2 for schedule.
Go ahead, Tim.
Jessica, just looking at our plan between Tim Peake and myself, he's going to start his JAXA task as soon as possible, and then we get closer to finishing up beam, maintaining the hour for fundoscope. He and I will split the ARED sessions then.
Copy, Tim. Stand by.
Jessica, one more piece on that. We'll have to do that 3 ways. I see Jeff has an hour scheduled as well, so we'll try to work that out.
Okay, Tim, that plan sounds good to us. Thank you. Thanks for being flexible.
Thank you.
And so the team's just needing to work out now the astronauts' exercise schedule, as they do have some tasks later on in this evening. And there is a constraint against a couple of the exercise devices while expanding beam, specifically ARED, the Advanced Resistive Exercise Device, and either of the 2 treadmills on board the International Space Station. So just making sure that the crew members are okay with deferring that exercise for a little bit later while not impacting, or maybe doing a couple of get-ahead tasks, moving some of them up earlier in the timeline so Jeff Williams can go back inside of Tranquility and resume this operation, which we expect to start shortly to be continue expanding beam.
Station Houston on 2 for Jeff and Beam.
Yeah, go ahead.
And Jeff, as soon as we get confirmation from the Russians that Oleg will not start any exercise on Bay Day 2, then we're going to resume the beam inflation.
Copy.
We're hoping to have that momentarily, so stand by and we can get going again.
All right, I'll be standing by.
And again, just confirming that no exercise on the treadmill is going to be started once the expansion of beam resumes. So we should just be moments away now from Jeff Williams once again opening up the valve, getting ready to put more air into this expandable module. So real close to resuming these operations now, just a couple of more moments.
And you're going to want this recorded on video?
Affirm.
Roger.
And this is Mission Control Houston. A quick handover with the communication satellites getting video back just momentarily. And once we do, NASA astronaut Jeff Williams should be getting the go to resume expansion operations with beams. So it's been a bit of a wait. The teams have looked over all of the data just to make sure that they are comfortable to proceed. But it looks like we're in a good position now, and Williams should be getting the call any moment now. As soon as we get this video communication back, look for Capcom Jessica Meir to radio up to the International Space Station, and we will once again resume operations to expand the Bigelow Expandable Activity Module.
Station Houston on 2 for Jeff. We're ready to resume. You can open the port for 3 seconds. That's 3 seconds.
Happy 3 seconds.
And Jeff Williams getting the call, the time going up 3 seconds this go around. So now resuming expansion of beam.
Our starting pressure is 18.7.
Houston copies.
After 3 seconds, our pressure is 21.2.
Houston copies.
And so with that, the valve open for 3 more seconds. Pressure reading coming down from Jeff Williams. So now the robotics officer will see if there's been any movement in the length and diameter of the module itself.
Scuba station on space to ground 2 for Auxin.
Station Scuba on 2, go ahead.
Good afternoon. I'm looking for a go please in step 1.2 for procedure 2.013.
Yes, you are go for step 1.2 in procedure 2.013. And let me make sure that you have completed the XS305 setup.
That's correct, and I'm going to be working in node 2 at the port MWA area if you want to follow along in the node 2 camera.
Okay, we would like you to use the XS305 camera in GEM.
Okay, Scuba Station, if it's okay with you, I'd like to work on the MWA. It provides a very good workplace for the whole afternoon's activity for harvesting these plants. I've got my setup there with all the harvesting tools, a stable platform, foot restraints, etc.
Checking.
And again, the team's now checking to see any difference in the size in beam following that 3-second introduction of air. And again, so far the module has increased about 5 inches in length from its original 85 inches when it was packed, and about 3 inches in diameter, that original diameter of 93 inches. The end goal's a 68-inch increase in length. And then the diameter will go from 93 all the way out to 127 inches once it's fully expanded.
And Jeff, if you could rotate the multimeter up a little bit, it's at the angle. We're having a difficult time seeing the reading right now. That looks good. Thanks, Jeff. All right, thanks, Jeff. That is a good view. And now you have a go for a generous 1 second.
Copy, generous 1 second. And initial pressure is 21.0.
Houston copies.
Ending pressure 22.3.
Copy.
And so another second of air into beam. The engineers continuing with the expansion operation, giving Williams the go just a few minutes ago to resume after, again, looking at all the data that's come down so far, the pressure readings, and how far beams, external coverings, everything has expanded so far along all of the operations so far this morning. And as we've done throughout the procedure so far, they're now again taking that pressure reading, looking at the robotic overlay to track how far along the module has expanded, and then using that to then calculate any additional introductions of air for Williams and how long he needs to hold the valve open.
Okay, Jeff, you have a go for 1 more second.
Copy, 1 second with a starting pressure of 22.1.
Houston copies.
Ending pressure 23.7.
Houston copies. And Jeff, stand by. We're assessing the data once again down here, so we'll let you know when we have an outcome.
Okay. Am I imagining it, or did we get about an inch displacement, actually?
Our assessment, Jeff, was no noticeable change, so we're still assessing.
Okay.
So the engineering teams, once again, continuing to look at the data. The robotics officer reporting that they're not seeing any noticeable change in this external view of Beam's expansion after the expansion operations resumed, and Jeff Williams giving 3 1-second introductions of air from the station into Beam. And so right now they're just, again, looking over all of the data, determining what the next steps are going to be, and then they'll be radioing that up to Jeff Williams. The team's looking if we're going to be able to continue this expansion process, again, requiring daylight and solid video comm. So there are time constraints that will come into play the longer that these operations go on. But for now, the team's evaluating next steps once again. Jeff Williams standing by on board the station, and Beam expansion still continuing. So continuing to stand by while the teams look at this data. So again, the engineering teams here in Houston, both those at NASA and those from Bigelow Aerospace, looking at all of the data that's come down so far. Beam's expansion, we started a little over 2 hours ago. Only a few introductions of air into the module so far. With the last three, the robotics officer reporting no noticeable difference in the length and diameter of the module itself. So they're, again, looking over their procedures, what potential workarounds, what next steps they can take to see if they can continue these operations. Again, we do require sunlight and solid video communication for all of these expansion operations to begin, and we still will start to run into some time constraints, especially as the current team on console, the Orbit 1 team, is getting to the end of their shift with that team led by Flight Director Brian Smith, who's been overseeing all of the planning for the ops team here in Mission Control Houston for this expansion. But for now, we're just standing by, waiting as the teams continue to discuss what these next moves are going to be. Jeff Williams standing by on board the International Space Station. Again, those first 3 steps taken today, which were done automatically through the beam expansion controller, closing the ascent vent valves, cutting the restraint straps, and releasing the forward bulkhead, done successfully. And we're in step 4 or 5, this manual expansion of beam. And Jeff Williams has introduced air through a series of anywhere from 1 to 5 second spurts, air flowing from the International Space Station itself into the Bigelow Expandable Activity Module. And again, as this process unfolded, Williams would then take pressure readings, feed those down to the ground, who would then compare that against the changes that they saw in beam shape, and then decide how long to introduce air on the next step.
Station Houston on 2 for Jeff.
All right, Jessica.
Yeah, Jeff, unfortunately, we're going to have to stand down with the beam operations today. We've been assessing all the parameters here from the ground, and due to our set of no-go conditions and not seeing any noticeable movement, we're going to have to reassess further from here. So we have a couple of actions for you to take to get us in a good position for that. First of all, we'll need you to cap the ISS sample port.
It's complete.
Okay, great. That will get us in a good config, and then you can stop recording then if you haven't already. We may later on, we'll get back to you, but we may have you swap out those multimeters. And then just to give you a big picture, we're hoping to resume with inflation tomorrow during orbit 1, but we'll have a status for you guys in evening DPC with follow-up there.
Okay, I understand. And I took the initiative since the controller is powered off, the KU power supply I powered off, and because we have a lot of potential energy on the other side here, I chose to drag that thing back into node 3. So I'm going to leave it in node 3 so we don't have a drag through, if you concur.
Okay, Jeff, good move. We concur with that. Thanks for all of your patience today, and we'll hope for better luck tomorrow.
Well, these are the kinds of things the team is up for the challenge for. It's space business. So thank you all for your patience.
Okay, we agree. Thanks, Jeff.
And so with that, you just heard Capcom Jessica Meir calling up to Jeff Williams that we are going to stop the deployment operations for today. The teams, the engineering analysis teams on the ground, not seeing the expansion that they were expecting along with the pressures along the pressure curve. So operations called off for now so they can continue to assess all the data that they've seen so far and then come up with steps. And as you heard, Capcom saying hopefully resuming tomorrow, but obviously that will be decided later in the day after all of the engineering teams are able to meet and then discuss next steps and how early they can give it another shot to try and expand beam. So obviously we will keep you updated on all of our different platforms on nasa.gov and across our various social media accounts where we stand with beam expansion and whether or not those operations will resume tomorrow or at a later date, as the teams again will meet over the next several hours, discuss next steps, and figure out when we will again resume the operation to expand beam.
We'll still want that set up for tomorrow, so you can leave everything as it is.
Okay, I understand. So the only thing I have left to do here is put ARED back in operational order.
Stand by 1 on that, Jeff.
And just a final recap on the day's operations, those first 3 stages of expansion today, closing the ascent valves, cutting the restraint straps, and releasing the forward bulkhead, done successfully, and the crew getting a little bit hung up in step 4, that manual inflation that, again, the teams are going to go forward, assess down here on the ground, and then come up with the next possible steps. We may be returning to operations tomorrow, but again, that will be decided in the next several hours once all the engineering teams from NASA and Bigelow Aerospace get a chance to meet and discuss what the path forward will be. Again, we'll be bringing you updates on any coverage times or any media availabilities or media teleconferences on nasa.gov. So be sure to just go to the homepage, look in the latest events, and be sure to follow along. As not able to get everything done today, but we'll again regroup, look at next steps, maybe back tomorrow. But we'll return again to expand this, the first human-rated expandable module to ever be flown in space. But for now, thanks for sticking around with us this morning, and we'll be sure to be back again soon here on NASA TV. But for now, we will go ahead and sign off. This is Mission Control Houston. Good morning from Mission Control Houston. Thanks for joining us on this weekend as we make another run at the expansion of the Bigelow Expandable Activity Module, also known as BEAM. You're joining us here inside of the International Space Station Flight Control Room at the Johnson Space Center in Houston, Texas, where the Orbit 2 team sits on console ready to once again make an attempt at expanding this module. Flight Director Brian Smith on once again to lead the team. Just next to him is NASA astronaut Jessica Meir, serving as the Capcom today, and she's going to be radioing up the calls from the team to NASA astronaut Jeff Williams, who's going to be hands-on inside of the Tranquility module for today's events. And for those that have been following along, this is the, again, second attempt to expand the Beam module. The first attempt made back on Thursday, where a number of steps, all of the initial steps were done successfully, but then after about 2 hours of the manual inflation or expansion period, the team ran into a couple of unexpected difficulties, stood down, and now we get to where we are today. Again, the initial expansion procedures for Beam on Thursday were done successfully, with NASA's Jeff Williams inside of Tranquility using the Beam deployment controller. All of the initial steps were confirmed to have worked successfully, so he was able to run the sequence on that controller and was able to first open up the ascent vent valves. These are two valves that were left open on Beam so it could be exposed to vacuum during launch and the flight up to the International Space Station as it rode up in the trunk of a SpaceX Dragon vehicle. Beam was extracted from Dragon back on April 16th and installed to the Tranquility module, where it sat for the last month and a half or so. And again, those ascent vent valves were the first items on the checklist on Thursday, and those were closed successfully. That just allowing Beam to then hold pressure, so those were first on the list. The second step was to release the restraint straps, 3 straps that you'll be able to see when we get the external views of Beam, and those were in place again just all throughout the launch and the installation periods, just to keep Beam in that packed configuration. And those restraint straps were cut. There was a 50-50 chance that it could have returned a false negative that they weren't cut, so Williams had to step through a process that was already built into the timeline for that event to just manually confirm that the straps were cut, and they were confirmed. All of the pyros fired and all 3 straps were successfully cut. And then once that was confirmed, Williams was able to then cycle the controller again, and that released the forward bulkhead. So there are 2 bulkheads inside of Beam, one on the forward portion, one on the aft portion. And basically these are just the 2 hard sections on either end of Beam that were held together during launch. And there were 4 struts connecting the 2 and 4 bolts that were then released, allowing the 2 to separate, and all of that setting up for that manual expansion. And that was step 4 or 5 that Williams stepped through for several hours on Thursday. just an iterative introduction of air into the module, and we'll see much of that same process again today, as that's where he's going to be picking up. Again, those first 3 steps already done successfully, so no need to recycle those today, but he'll be picking up with the manual inflation, the manual expansion of Beam, transferring air from the International Space Station itself into the Beam module using a small valve and doing it for a determined amount of seconds at a time. Those numbers being calculated by the flight controllers and the engineering teams from NASA and Bigelow Aerospace working here in Mission Control today. And you'll hear the Capcom Jessica Meir radioing those up to Jeff Williams throughout the operations this morning. And again, back on Thursday, Williams was able to introduce air over a period of about 2 hours, usually for several seconds at a time, starting out at 5 seconds and then giving it a few 1 second, 1.5 second bursts before the teams eventually stood down. They saw good expansion on Beam at the very beginning. Beam's packed configuration of about 85 inches in length and 80 inches in diameter, which then expanded out to 84 inches in diameter after those restraint straps were cut. And the key numbers to look for, as we will be seeing an overlay grid from the end of the station's robotic arm, in order to begin the pressurization of Beam, which is the final step in the process that we're hoping to get to today. Beam's diameter will need to increase from that 84 that it was at for the post restraint straps all the way out to its final radius of 127 inches. And then we'll also be looking at the length, so you'll hear numbers called out axially and radially. Axially is the length, so the left to right that we're going to be watching on the grid. And then radially is going to be the diameter, so the up and down that we'll be watching. Again, that final diameter needs to be 127 inches. Back on Thursday, it expanded out to about 96 before the team stood down. And again, the team standing down is they're going to be monitoring a combination of Beam's expansion, so both, again, along the diameter and the length, but they're also going to be monitoring the pressure inside of Beam. And you'll hear them talk about things called the safe pressure curve, where using a combination of those numbers, they're able to keep track of where they should be in the process. And the reason that operations were stood down on Thursday, where they were seeing the pressure rise, but they weren't seeing the corresponding increase in the diameter and the length. So the team's then standing down to go and talk about additional options, what they could do to get around this and begin or continue expanding Beam and get back to normal operations. Again, after they stood down on Thursday, they let Beam sit pressurized overnight and throughout the day on Friday, and actually saw that diameter increase from 96 inches all the way out to 111, and the length, we had seen a 5-inch increase on Thursday, and that increased another inch over the last 24 hours out to 6 inches. And the final length that we'll be looking for is 158 inches. It only has to get a little bit less than that, so when we see the grid, you'll see a number of lines at the end, just around the number 70. It needs to get out to at least an increase of 68 inches in order for the pressurization step to commence. And then at the final end of all the operations, after Beam's been pressurized and after everything's said and done, it will have increased an additional 73 inches to that final length of 158 inches. So we'll be looking for those increases today as they get ready to introduce air back into Beam again. And the operations, again, concluded on Thursday. The teams then stood down, looked at the data, talked over how the events progressed, and looked at any potential causes of why things didn't go exactly per their predictions. But again, these were very conservative predictions, as this is the first time that we've ever expanded a module on board the International Space Station. The first time a module has been expanded in the presence of human beings, of people. Bigelow Aerospace, which built, designed, and delivered Beam to NASA for this technology demonstration, has flown 2 expandable habitats in space already, Genesis 1 and 2, but those were free flying, and the expansion process was significantly different. This an important step in understanding how we're going to be able to expand these habitats in an environment with human flyers. So as any time you add humans into the loop, there are some more safety restrictions, some things put in place, again, just to protect the safety of the crew, which is always paramount. And everything that we're learning right now from this expansion operation, very important, and it's all definitely a learning process, and everything that the teams are able to glean from the expansion activities on Thursday and today will directly influence the design and the operation of expandable habitats in the future. So even this slow iterative process that we saw on Thursday and we may see again today, definitely a learning experience for all the teams and very valuable. But today's operations will pick up in just about 6 minutes or so. As on Thursday, it is a requirement to have good video communication and sunlight so the teams down here on the ground can track Beam's expansion process. Keep an eye on the length and the diameter, as the only view that they have to work with are these external cameras. And the main one that we'll see will be on the very tip of, you'll hear it called the lee. It's the latching end effector. It's basically the very tip, the grabber part of the station's Canadarm2 robotic arm that was used to install Beam, again, just about a little over a month ago to this port on the Tranquility module. And so we'll need that sunlight and that video communication, which we'll pick up in just a couple of minutes. And then Jeff Williams will once again be hands-on inside of the Tranquility module, introducing air through a small valve into Beam to get it expanded. And if things go well today and Beam's able to take its full shape, that will complete step 4, and then step 5 will be able to kick off, and that will be the pressurization of Beam. So once it's attained its full shape, the pressure inside the module will actually be very low, less than 1 psi, less than 1/2 psi in fact, and it will need to obviously be pressurized up to the full pressure that the International Space Station environment is at before the hatch can be open, and that's 14.7. So there are 8 air tanks inside of Beam that they'll be able to then open up, pressurize the module, and then set up for a series of leak checks before the crew members first go inside about a week after. So again, we're just a few minutes away. Some of the key players that you'll be seeing and hearing today, again, Flight Director Brian Smith leading the team, NASA astronaut Jessica Meir, the communication voice for the teams on the ground that will be calculating the amount of air that Williams will be putting in, and you'll hear Jeff Williams again calling down pressure readings and a number of other data points for the teams to then make their calculations. Again, after each introduction of air, Williams will pause. He'll take a pressure reading and call that down to the ground, and then a combination of the engineering teams, the Ethos flight controller, and the Robo flight controller here in Houston will monitor the pressure. They'll figure that in with any increases that we see in the length and diameter, and then using that, they'll plug it into an equation and then get a number for how many seconds Williams will then be given the go to open up that valve and introduce more air into Beam. And so getting that video comm now, so it should just be a few moments away from the beginning of operation. There you can see Beam in the robotic overlay I was talking about. The key things to look at, if you look on the far right of that plot, you'll see a couple of lines around the number 70. That first line just to the left of it is 68 inches. That's where we need to get before the pressurization can begin. And that line just to the right is 73, which is going to be the final length increase of Beam by the end of operations. Again, the full length of Beam will be 158 inches, but we're looking for a total increase of 73 from its packed configuration of 85. And one final note, after all of the operations and after all of the monitoring yesterday, Williams did actually depressurize beam. It was not brought down to vacuum, but they released a significant amount of the air, bringing it down close to vacuum. And the reasoning behind that, the prime suspect for the difficulties with getting beam fully expanded on that first go on Thursday were that the engineering teams believe a little bit higher than predicted friction forces between the soft goods that make up all of beam's outer and inner layers. And so with that prediction now in place, hoping to refine their models and then introduce additional air into beam today. And the module was depressurized, hopefully allowing those soft good layers to settle a little bit, possibly unstick them in a very general sense, and then allowing the layers to settle, and then hopefully allowing for a more successful expansion opportunity this morning.
Go for step 1 in the XTP version of 1.302.
Step 1 of 1.302 in work. And P1 is 2.3 millimeters.
Houston copies.
And Jeff Williams there inside Tranquility, going through the initial steps before we can begin this expansion process. Again, we have good video comm for about the next hour or so, and as we are in what's known as a high beta period, so a very high amount of sunlight being on the International Space Station, sunlight will not be a concern, so should have plenty of time for this initial go through to try and expand beam.
P2 is 1.0 millimeters.
Houston copies.
And this initial opening of the valve expected to be significantly longer than anything we saw on Thursday, as again beam, even though it was depressurized, has mostly maintained its volume. So they'll have a much larger volume to work with, and all of their safe pressure curves to allow for basically an equivalent volume of air that went in on Thursday to be introduced in the first opening of the valve today. So while the longest that we saw on Thursday was about a 5-second opening, we can expect to see about a 22-second opening for this first introduction.
A little bit. Our ideal view would be so that we can actually see your hand on the valve, but still read the multimeter.
In Houston, we're ready for beam inflation.
Houston copies. All right, Jeff, we are ready for you in step 4.9. Your first value will be 22 seconds. That's 22 seconds.
22 seconds. You were very generous.
We are feeling generous this morning.
Twenty-two seconds. Pressure is 19.0.
Houston copy. Stand by while we take a look.
And so the valve opened for the first time. That 22 seconds, the initial introduction of air from station into beam. And for now, the team's going to monitor for the next several minutes or so, look for any changes in beam shape from the external camera views that we have, and then they'll again converse, reassess, take a look at the pressure, take a look at any changes, and then come up with any number of seconds that Williams will once again be allowed to open up the valve and put more air into the module. So now we'll go ahead and keep an eye on beam and look for any motion. And so that initial introduction of air, again, the valve opened for 22 seconds. This more or less getting us back to the same amount of air roughly that was introduced on Thursday. And this will then allow the teams to go back, reassess, and then come up with whatever number that all of the engineering teams agree on that Williams will be able to open the valve again. They could let beam sit for about 10 minutes or so, as we have seen it can take a little bit of time for the module to settle out and begin moving, as we saw just from the end of operations on Thursday when the module was at a diameter of 96 inches.
A full 10 minutes to really assess things from the ground, so 10-minute wait.
Okay, thanks for that.
And you just heard Capcom Jessica Meir calling up. They're going to take about 10 minutes to look at things on the ground. Allow beam to just settle for a little bit while they look at the numbers, run everything, and then call up another, the next set of instructions for Williams, and hopefully get this valve open again for a number of seconds. But again, as we saw just from the end of Thursday to yesterday, when Beam was allowed to just sit, it expanded in diameter from 96 inches all the way out to 111. And even this morning, the robotics officer reporting the diameter at 113. So Beam continuing to expand. Again, its final diameter will be 127 inches, so well on the way to getting this module expanded. I'm also hoping for some more increase along the axial, or basically the length of Beam. So far only 6 inches. We need to get out to 68 to then do the pressurization steps. So the team's going to keep a close eye on Beam here, and then come up with a number that will be radioed up to Williams in the next 10 minutes or so. So we'll just stand by for a little bit and hopefully resume with some more expansion of Beam. For those just tuning in, the expansion operations of Beam have begun for this morning. The second go at expanding the module. The valve already opened once for 22 seconds by Jeff Williams. Now just standing by for the teams to assess where everything looks with pressure and beam size before Williams gets the go to once again open up the valve. Should be coming in the next minute, just a couple of moments from now.
Okay, Jeff, that was a little bit less than 10 minutes, but we're actually ready for our next pulse. We would like you to now open the valve for 8 seconds. That's 8 seconds.
Happy 8 seconds. Pressure 23.7, no 6.
Houston copies.
And this time the valve opened for 8 seconds. And now we'll see if the module begins to expand at all. Again, looking for both expansion along the diameter and in the length.
And some little popping on the other side. Maybe 3 short little pops.
Okay, good news. Thanks, Jeff.
More pops.
We copy.
Jeff Williams reporting, hearing a couple of popping noises. Those are expected, as you heard Jessica Meir say, good news. Those are the ripstop straps, a measure in place to help hold beam into its packed configuration, but expected to rip as this pressure begins to slowly build up. So that is a good sign, hopefully getting some motion in beam structure. We'll stand by to hear if the robotics officer is able to see any significant changes.
One more pop. Two more pops.
We copy.
Couple more pops.
Great news. Copy, Jeff.
And a couple more pops.
We copy. And Jeff, just big picture, once you stop hearing the pops, we're going to let things stabilize for a little while, so just keep us posted.
Okay.
And so the team's reporting here inside of Mission Control, seeing some motion in beam, hearing the good news from astronaut Jeff Williams as he's hearing the pops, the rip stitches beginning to rip out as expected, as planned, meaning that the module is beginning to expand. So getting some good news from that last pull of, or that last push of 8 seconds worth of air into beam from station. And this a view from one of the cameras looking up at beam from the back, so you can see it has definitely begun to take a little bit more shape since this second introduction of air. Again, Jeff Williams kicking things off this morning at 8:04 a.m. Central with a 22-second push of air into the expandable module. The teams sat and let it expand a little bit and then ran their numbers real quick and then gave him the go for 8 seconds, which he opened the valve at 8:13 a.m. Central, and now hearing the ripstop straps and getting some motion on beam.
Okay, we copy, Jeff. Thanks for the report.
And the team's continuing to just sit and waiting for beam to finish expanding out a little after this second introduction of air this morning. Again, the first 22 seconds, the second 8 seconds. And once it stops motion a little bit and the pressure stabilizes, the teams will once again run the numbers and give Jeff Williams a call on how long to open the valve for the third time. But again, seeing good motion, seeing good data, and seeing good expansion so far this morning on beam.
And Houston, just to characterize this a little bit more, I might get 10, 15, 20 seconds go by and then get a series of random little pops. And it sounds sort of like when popcorn in a frying pan starts up. And then I might get 3 or 4 of them, and then another 10 or 15 seconds, and then get another couple. So they're just random, but they're continuing.
All right, we copy, Jeff, and that is what we were expecting. So that's good news, and please keep us posted.
The good news continuing to roll in today for this second attempt at beam expansion. Again, the valve has been opened twice so far this morning. First at 8:04 a.m. for 22 seconds, then again at 8:13 for 8 seconds. The astronaut on board, Jeff Williams, reporting that he's hearing those rip stop straps breaking, which is exactly as they were designed to do as the module slowly expanded. So getting good call downs from him and continuing to watch the pressure, and then also any increase in size both in the diameter and in the length. But the teams down here on the ground definitely seeing beam slowly begin to expand out.
Displacement is about 9 inches.
Copy, thanks.
And we've seen quite a growth in the diameter as well.
Okay. In Houston, the random and infrequent popping continues. Sometimes now I get 30 to 45 seconds in between, say, 2 or 3 pops. So that they're becoming a little more infrequent.
Okay, copy that, Jeff. Thanks. And just to let you know, we do see a little bit more axial displacement as well. We're now at 10 inches, so I think it's still moving.
Concur.
Beam is continuing to slowly expand outward. The teams, again, I'm seeing good data so far, good performance on the module with everything so far this morning. Those first 2 bursts of air seeming to get us past the holdup from Thursday. And Jeff Williams reporting that he's hearing some pops inside. Those the rip stop straps breaking as expected. Beam continuing to expand in both directions as was expected, predicted, and hoped for. So both across the diameter and across the length. The teams are going to continue to monitor the module. Once it settles out a little, they'll then look at all the numbers and then come up with another length of time for Jeff Williams to open up that valve. But for now, just standing by for the next couple of minutes while Beam continues to slowly expand outward, and then getting ready for the resumption of putting air into this expandable module.
And Jeff, big picture for you so you can follow along. I know I described it to you last time, but just to be a little bit more clear in my description, it's that bottom grapple fixture that we're looking at for the axial displacement, and it's where the pin meets the base plate. So it's a little bit tough to see because that point where it meets the base plate is, of course, a little bit obscured by those cams, but that's what we're looking at for the axial displacement.
Okay, I understand. The random infrequent popping continues.
We copy.
And Jessica Meir referring to the overlay grid that we have on your screen right now if you want to follow along.
More essay. If you can see the second orange line on that overlay, that's where those ADSS struts will be deployed.
Say again, what will be deployed there?
The second orange line on the overlay, so with the vertical lines, you can see most of them are green, and then you have 3 orange ones. The second orange one, which is just before 20 inches, that's where the ADSS struts will be unfolded.
Okay, got it.
And that second orange line that Capcom Jessica Meir referring to just before the 20-inch mark.
Cycle the multimeter for us.
And that is where the ADSS struts, as they're known, will deploy. And those are the anomalous depressurization and stabilization system struts. There are 4 of them inside of the expandable module. And essentially those are what will help ensure that the module can keep its basic structure even in the event of a loss of internal pressure. That obviously very important for the eventual removal of beam by the robotic arm, to make sure you have this rigid structure that won't move around while in motion. Again, that'll be a significant event during this expansion process when we reach there. But if you're looking at this grid, and you can, it is a bit small, but if you can get very close to your screen, what they're tracking for the actual length expansion is, if you look at the grapple fixture, so that part, that metal piece on the bottom jutting out at about a 45-degree angle to the right from the right side of beam, you'll see a small pin which is used to help guide in the robotic arm's grapple fixture, and where that pin meets the flat plate is where they're actually looking. So you can see it's just a little bit at or beyond 10 inches right now. And again, we'll be looking for that to go all the way out to that orange line just before 70 at 68 inches, which will mean the step 4, the manual expansion process, will be complete, and then we can go into the actual pressurization of beam, at which point it'll expand out another couple of inches to 73 total, giving it an overall length of 158 inches.
And Jeff, looking at that overlay a little bit further, so for that third orange line is where we're trying to get today. That 68 inches will be when we are complete with a manual inflation.
Beam continuing to slowly expand, as again there's only been 2 openings of the valve so far, the first time for 22 seconds, the second time for 8 seconds, and we do have about 20 minutes or so of video communication with the International Space Station. So in the event that we aren't able to get Beam fully expanded in that time, we will have to stand down for about 30 to 40 minutes until we reacquire that video communication. But everything going smoothly so far this morning, seeing good expansion both along the length and the diameter of Beam, and the pressures well within what was expected. And for now, just standing by until things settle out and Jeff Williams gets the go for the next period of introduction of air into Beam.
What I would call random infrequent popping continues.
All right, Jeff, we copy that. Axial displacement now looks like we're about 12 inches, and we would like you to open the valve this time for 3 seconds. That's 3 seconds.
Copy, 3 seconds. Pressure 18.7.
We copy.
And the popping continues at a, of course, higher frequency.
All right, all good news. Thanks, Jeff.
So the valve between the Tranquility Module and Beam opened.
If you could flip on the mic for the Node 3 camera just so we can get a sample of those popping sounds, that'd be great.
So again, the valve opened once again, this time for 3 seconds at 8:38 a.m.
Are you able to hear them?
Yeah, we can hear those. Thanks, Jeff.
I'm going to give you a short sample now of the audio that Williams is hearing inside of Tranquility, and you'll hear those occasional pops that he's been reporting. Continuing to see good expansion in beam, again, both along the length and the diameter. 3 bursts of air so far this morning, 22 seconds, 8 seconds, and 3 seconds. Continuing to hear the occasional popping noises as expected as the various restraint straps, rib straps inside break as expected while the module expands out under this pressure.
Jeff. Maybe that 20-inch mark or that second orange line is where we transition from using station pressure to using those internal tanks.
And beam continuing to expand, again seeing good data from the teams down here on the ground. 3 bursts of air so far into the expandable module. First at 8:04 a.m. for 22 seconds, basically getting us back up to the amount of air that was in there on Thursday. And then another at 8:13 a.m. Central, 8 seconds of air. And the most recent at 8:38 for 3 seconds, continuing to see good motion in the beam module. So the robotics officer reporting we're at about 14 inches increase in length so far, and the diameter continuing to increase as expected as well. And as expected, losing that video comm with the station, so we will likely have a pause now in the expansion operations, as that video communication, one of two requirements along with sunlight for the ground to continue these operations.
And Jeff, you can turn off that microphone now if you like. We did have a good sample of the noise, so thanks for that, but we don't need it anymore if you want to turn it off.
Okay, audio should be turned off.
All right, thank you.
And is that the noise you expected?
Affirm, Jeff, that is what we expected, so that is good news.
So we'll stand by for just a couple of minutes. We might get a little bit more video down from the station. There it is, just coming back up for a few moments. But again, we are looking at a pretty significant gap in video comm coming up before the top of the hour, so the teams will likely stand down on expansion operations until that communication resumes. Currently targeted to be just a little bit after 9:30 a.m. Central. So we'll stand by for a few more moments, then likely take a break in our coverage until this video communication locks back up later on in about 40 minutes from now. So stand by for just a few more moments. Again, seeing really good motion so far in beam, both lengthwise and in the diameter. The module definitely expanding much closer to as predicted. And getting good news, good reports from Jeff Williams on board in terms of the sounds that he's hearing. All the engineering teams getting much better news with this second attempt at expanding the module today.
Okay, Jeff, you have a go to give it a 1 second pulse, so 1 more second. After that, we're going to be going into a big KU blockage, so we're going to have to take a break and resume around 14:35.
Copy, 1 second, and then the break. Sure.
And Jeff, we had a hand over there. What was that last pressure that you read?
It was 17.0, now it's 16.9. And the call I made is I did not hear any subsequent popping subsequent to the 1 second, but since then I've heard 2 or 3.
Okay, Houston copies.
I understand we're still going to go with that break now, right?
Stand by, Jeff. All right, Jeff, we have a little bit of bonus KU here right now. If you could tilt that multimeter up just a little bit, we're getting a little bit of glare on that. So we'll take another few minutes here to take a look before we send you off on your break. That looks good. Great view, Jeff. Thank you.
And with that, now in that extended, call it a KU gap, so basically not going to have that video data link to the International Space Station for a pretty significant amount of time, so the expansion operations will stand down until then. And with that, we're also going to stand down from our coverage for just a little bit. We will resume shortly before the video picks back up here on NASA TV, so we'll go ahead and take a break for now and pick back up at 9:30 a.m. Central Time, 10:30 a.m. Eastern. It's just about 5 or 6 minutes before expansion operations will resume. So just to recap, everything going much smoother so far this Saturday morning, with 4 bursts of air already going into beam, first at 8:04 for 22 seconds, 8:13 for 8 seconds, 8:38 for 3 seconds, and one final pulse of air for 1 second at 8:52 a.m. Central. So we'll resume back up once we get that video comm at the bottom of the next hour at 9:30 a.m. Central, 10:30 a.m. Eastern. So be sure to take a break and then tune back in just a little while as we resume the expansion of the first human-rated expandable habitat ever flown into space, the Bigelow Expandable Activity Module. For now, we'll go ahead and sign off, though. This is Mission Control Houston. Once again from Mission Control Houston, and welcome back to our ongoing coverage of the expansion of BEAM, the Bigelow Expandable Activity Module, the first human-rated expandable ever to be flown into space. We're just a few minutes away from resuming operations as we stand by for the next 5 to 7 minutes to resume this video communication with the International Space Station, a requirement for all of the operations today, as the teams down here in Mission Control, both engineers from NASA and Bigelow Aerospace, continue to monitor the module's progress, which has been going much better today. Just to recap, so far this morning, 4 bursts of air have been introduced into Bigelow from the International Space Station by NASA astronaut Jeff Williams, who's operating the valve manually to transfer this air and expand the module. That first valve opening came at 8:04 a.m. Central Time and was open for 22 seconds, essentially getting the module back up to roughly the same volume of air that was in it during the first attempt back on Thursday. Following that, the teams looked at the data, looked at the shape, the size of beam, and also the internal pressure, and gave Williams the go for another 8 seconds of air at 8:13 a.m. Central. Following that, we started to see some good motion in beam, the length and diameter beginning to expand outwards. Also, Jeff Williams reporting that he had begun hearing a series of popping noises, something that was expected to happen, and indicated that the ripstop straps were beginning to release, indicating that the module was once again in motion, beginning to expand out, and all of that was good news to the engineering teams down here in Houston. The third introduction of air took place at 8:38 a.m. Central, 3 seconds, and by that point the module had expanded out up to 14 inches in length. Again, that magic number that we'll be looking for is 68 this morning. Once beam has expanded 68 inches from its packed dimension of 85 inches, it'll be then ready for the pressurization phase, which will be the final step in today's expansion activities. And then the fourth burst of air, a short 1-second pulse, took place at 8:52 a.m. Central, just before we lost that video communication with the station, and now we are just standing by. Once we resume comm, will be able to take a look, the robotics officer here in Houston, able to look at the overlay that we'll see throughout the operation today, see just how much beam has changed in the last 30 to 40 minutes or so. And then they'll be able to get a pressure reading from Jeff Williams on board, look at both the length and the diameter of beam. And then the teams will once again converge, come up with a number for Williams to open up the valve again, and we will continue this expansion process. It's been a slow, iterative process so far, but we've again seen good motion in beam, the module behaving much better today than the bit of friction that we saw on Thursday that caused the teams to stand down and reevaluate over the last day or so. But again, seeing good operation so far, good expansion in the module, and we should be resuming in just about 5 minutes or so. Again, beam attached to the aft port of the Tranquility module, also known as Node 3, same module that contains the station's cupola, the large 360-degree window on the Earth-facing side, also the permanent multi-purpose module just opposite of beam on the forward port. Also inside Tranquility, one of the 2 toilets on board the station, and also the astronauts' workout gear, the treadmill, the T2, and also the advanced resistive exercise device. But Williams will be in there at the hatchway into beam, introducing that air throughout the rest of this morning until this module is fully expanded. And beam, an important technology demonstration, so everything that we're doing today and everything that was done on Thursday, very important for the learning process, the analysis process for NASA and Bigelow Aerospace as we continue to really get into the world of these expandable modules, which can be launched at a lower mass and a lower volume than traditional rigid hard metal modules, and then be expanded in space, potentially even offering an increased amount of living volume inside. And something like that could obviously be valuable for space stations, not just the International Space Station, but private space stations, but also as habitation for any cislunar, so the area around Earth and the Moon, and then for the eventual journey onto Mars. So expandable habitat's one of those many technologies being tested right now on board the International Space Station that will directly influence the design of future spacecraft. Expandables are one of those potential technologies out there that NASA, the international partners, and a number of other both private and government spacecraft designers looking at as possibly including in their spacecraft architecture for plans in the future. So very exciting, a very useful, very important demonstration in beam. Everything we're doing, definitely a part of the learning process, is this is the first time that a human-rated expandable has been flown in space. Again, Bigelow Aerospace, which designed and built beam, has flown 2 expandables previously, the Genesis 1 and 2, but those were expanded independent of any other structure. And so obviously any time that we add humans into the mix, a little bit more conservatism, more safety procedures in place, as the safety of the crew and the International Space Station paramount in this exercise. But the teams carefully watching everything, not seeing any issues with beam or with the station itself, and everything proceeding very smoothly, if a bit slowly, this morning with this expansion process. So the team's seeing good data, and now just standing by and looking like the video comm is coming back up. So we should be able to resume this operation very soon. And getting our first look now at beam since we last saw it just about 40 minutes or so ago. Definitely some increased expansion along the lengthwise. We'll wait and hear just how much, but again, Jeff Williams should be getting the call shortly from the Capcom here today, Mission Control Houston, NASA astronaut Jessica Meir, once the teams are ready to resume the expansion operations. And the robotics officer reporting we're at a distance of about 16 inches in increased length so far. Again, the magic number that we're going to be looking for is 68, at which point the pressurization of beam will be able to begin. Beam started from a length of about 85 inches and will ultimately be out at 158 inches, so 68 is that number that we're looking for to begin pressurization. Once pressurization is all done, it'll have increased a total of 73 inches from that packed configuration and be at its total length of 158. So again, since that last 1 second burst of air, we've seen an increase in about 2 inches over the last 40 minutes. And then, so for now, the teams will take a look at the pressure, compare that with the diameter that they're seeing on the inner structure and also the length, and then they'll be able to then calculate a value of how much air Jeff Williams will now get to introduce for this next step. So stand by for a few minutes, should be getting that call in the not too distant future, and Jeff Williams resuming the manual expansion of the Bigelow Expandable Activity Module.
And Houston Station on 2, current pressure 15.6, and I just put a new card in the video recorder.
Okay, copy both, Jeff, and we'll be back with you in a minute to give you your next opening value.
Copy.
Okay, Jeff, you have a go to open the port for 1 second. That's 1 second.
Copy, 1 second. And I'm going to give you audio as well.
We copy, thank you.
Pressure 16.2. I heard 1 single pop.
So the valve opened one more second. So now we'll again stand by and see any expansion progress in beam. Again, getting very close to the deployment of what you'll hear called the ISS, the Anomalous Depressurization and Stabilization System. And that's a series of 4 struts designed to help beam keep a rigid shape for when the module is eventually unhooked from the common berthing mechanism on Tranquility at the end of its 2-year mission, and then released by the Canadarm2 robotic arm. And that should be coming up very soon. But continuing to see good motion in the module so far this morning. You'll get a bit of the cabin noise that Jeff Williams is hearing, and you may hear a popping noise every once in a while. And again, those are planned and in fact encouraged, as that is the various rip-stop straps inside breaking, indicating that the module is continuing to expand. And so for now, the teams, again, looking for any changes, not seeing any changes after that last second so far in the length or diameter of beam. So they'll just continue to monitor for a few minutes, look at the pressure, and then again, go down to their calculations and come up with a number for Williams to open up the valve again for additional air. But the 5th introduction of air so far this morning, as things kicked off at 8:04 a.m. Central Time. But beam definitely moving along, getting closer to that bingo mark of 68 inches, which we need in total expansion.
And since that 1 second, I probably heard 6 or 8 of the popping noises, and it's been quiet for the last minute and a half or so.
And for those just tuning back into our coverage, the expansion operations have resumed. Jeff Williams at 9:42 a.m. opening up the valve for one more second, releasing a small bit of air into beam. The team's now assessing any increases in length or diameter. Not seen any so far off of this last introduction, but also looking at the pressure and then discussing down here on the ground for how much air they're going to want Williams to introduce on the next go around. So the team's just going to assess over the next several minutes. Engineers from both NASA and Bigelow Aerospace working in tandem throughout all of these operations today, and then we'll stand by until Williams gets the go-ahead to open up the valve once again. Just to recap, we've had 5 pulses of air so far through that valve. The first one for 22 seconds, the second for 8, the third for 3, and the last 2 for 1 second at a time, giving a total of 35 seconds of air so far into beam, over 5 different openings of the valve between Tranquility and the Bigelow module. The team's conversing for the next minute or so before we get the next call up. And so standing by for just a few more moments while the teams come to a final consensus on this next amount of air that we're going to be able to introduce into beam. But again, getting good motion so far from the 5 pulses of air that Jeff Williams has been able to open the valve up so far. Beam a little more than 16 or 16.5 inches along the length so far. Again, looking for that to get out to that magic number of 68, at which point the manual expansion process will be considered complete, and then we'll be able to kick off the pressurization phase of beam, and that will involve the opening of 8 air tanks located inside of the module itself, which will be used to pressurize the module up to the same atmospheric pressure as the rest of the International Space Station. which is kept at 14.7 psi, the same air pressure that we enjoy at sea level down here on planet Earth. So just to keep the astronauts in a fairly similar environment to what they're used to in daily life here. But beam will ultimately be pressurized up to that, and that will wrap up the operations for today, pressurization being in the final step, and then just some teardown activities for Jeff Williams. And then again, following the successful expansion of beam, it will kick off about a week-long process of leak checks and other activities before the crew members get the go to open up the hatch and perform what we'll call the first ingress, or the first time they'll go into the module. That was originally scheduled to take place on Thursday, June 2nd. That time will obviously need to move to the right as the expansion itself has moved. So we'll be sure to get you a new update once an update on that date once the module is fully expanded. But for now, continuing operations today, standing by for the next opening of the valve. The teams here in Mission Control Houston from NASA and Bigelow Aerospace continuing to discuss, and should be getting an answer through the Capcom Jessica Meir up to Jeff Williams in a couple minutes from now. So we'll continue to stand by, getting some good views still of beam through the various cameras, both on the along the robotic arm on the tip and on one of the elbow joints of the arm itself. But as you can see, we've come a good ways from where we started earlier this morning with the first introduction of air at 8:04 a.m. The operation's continuing along, and hopefully should be seeing beam expand out to that full size, hopefully during this communications pass, as we do have video until about 10:42 a.m. Central, so we have about the next 50 minutes to hopefully get it completed during this pass. So we'll continue to stand by and follow along as Jeff Williams continues to expand this expandable module. For those just joining, we are continuing to stand by for the next pulse of air from the valve on board the station, putting air into beam. We've done 5 so far this morning, starting off at 8:04 a.m. Central Time, 9:04 a.m. Eastern. All told, 35 seconds, the valve has been opened to flow air from Tranquility into Beam. We've seen an increase all the way out to 17 inches now so far. And we started off at 6, so a very significant increase so far along the length in Beam, and the diameter continuing to expand along with it, much closer to all of the initial predictions. So all of the data looking good so far for the teams here in Mission Control. Within the next couple of minutes, we are expecting a decision on how much air we'll be able to put in on the next go-around for Jeff Williams. Again, the most recently just opened the valve up for another second at 9:42 a.m. That's been the only one so far since we resumed our coverage. But we'll just, again, continue to stand by for the next several minutes while the teams from NASA and Bigelow converse and come up with a solid number that'll then be relayed to the team here in Mission Control for Capcom Jessica Meir to call up to Jeff Williams, who's standing by on board the station.
And Jeff, we are still talking things down here, kind of like the other day. We're up against those safe pressure curves, so we're deciding on what our best strategy is to try to continue getting this thing expanded. And if you could please power cycle the multimeter at this time, that'd be great as well.
Okay, I'll put that to work.
And Capcom Jessica just radioing up, letting Jeff Williams know the team's still in their final discussions down here on the ground for the next step forward. Again, the team's still looking to press ahead with this expansion so far this morning, just going through all of the discussions for just how much air, how much that valve needs to be open to continue right along. Again, you'll hear a mention of the safe pressure curves. These were simulations run and prediction plots formed in order using a combination of the pressure readings inside of Beam and the volume. So looking at the length and the diameter of the module itself, all of those being plotted out just to ensure what is conservatively a safe pressure to be at, to protect for any loads being transferred back into the station were Beam to spontaneously deploy. So again, as this is a technology demonstration and the first time that we've ever expanded a module like this on board the station, the team's building in some extra caution, some extra conservatism to make sure that we're not ever putting the crew or the station itself at any risk during this expansion operation. And again, at any point during this expansion, both Beam and station will always be left in a stable configuration. But for now, the team's just discussing to get down to that final number that they'll be able to radio up to Jeff Williams and continue this expansion process so far this morning. So again, just going to continue to stand by for a few more minutes. Beam not really changing shape right now, but hopefully getting it out to this full expansion in the not too distant future, getting it pressurized and wrapping up the expansion of the first human rated expandable module ever to be flown into space.
Okay, Jeff, we're ready to resume with another pulse. Please open the port for 5 seconds. That's 5 seconds.
And so there you hear Jeff Williams getting the call to open up the valve for 5 more seconds. We'll see him float into view there.
Copy, 5 seconds. Pressure 17.6.
Houston copies.
And there we have the 6th opening of the valve today. Another 5 seconds, that happening at 10:10 a.m. Central Time.
Pops.
All right, copy. Good news.
Williams reporting he's hearing another series of pops. Good news. That means the module is moving again, and those rip stop straps are breaking as expected. And once again, we're back in that watch and monitor situation. We'll wait and see just how much beam changes in size after that last 5-second pulse of air from the valve between Tranquility and beam. And then once again, the teams will get a pressure reading, look at the length and diameter of the module itself, and then come up with a new number. But that, again, the 6th opening of the valve so far this morning at 10:10 a.m. Central Time for 5 seconds. Now we're just going to stand by and watch beam for a couple of minutes, see any changes in the shape, and then resume operation shortly thereafter.
By the way, that last pressure pulse seemed to be pretty productive. Lots of pops.
All right, good to know, Jeff. Thank you.
The teams here in Mission Control Houston continuing to monitor beam's progress. Again, just looking for any changes in the length and diameter in the module after that 6th pulse of air through the valve, connecting the air supply inside of the station to beam. That last pulse of 5 seconds coming at 10:10 a.m. Central Time. Getting constant pressure readings from a multimeter inside of Tranquility, and also looking at the robotic overlay and the external camera views to see just how far along beam has gone. Again, we started off with an increase of only 6 inches from all of Thursday's operations from its packed configuration, and now out well past 17 at this point. We'll stand by for the next call from Robo on just where the module settles after that last pulse, but that magic number we need to get to is 68, and that'll signify that the manual inflation, the introduction of air part of beam will have been finished, and then we can move on into that pressurization phase. The Robo just reporting the increase in axial distance, so the length of beam now up to 18.5, so up another 1.5 inches from before this last 5-second pulse. Another good increase in the diameter too. Looking at the inner diameter, which is now visual for the teams down here on the ground, up to about 115 inches. And again, with that most recent call out from the Robo, seeing the length increase to about 18.5 inches. The team's reporting it'll be about 5 minutes or so until they're done running the numbers and able to get the next amount of air, the next length of time that Jeff Williams will be able to open up that valve. So we've had 6 so far. the last one coming at 10:10 a.m. Central Time, so just 10 minutes ago. All told, we've had the valve open for 40 seconds so far this morning, able to introduce air into beam.
Okay, Jeff, we're ready for another value. This time, please open the port for 3 seconds. That's 3 seconds.
Copy, 3 seconds. Pressure 17.7, and I'm getting some pops.
We copy the pressure, and more pops is a good thing. Thank you, Jeff.
And so with that, the 7th opening of the valve for another 3 seconds, giving us a total of 43 seconds of air so far this morning. Jeff Williams reporting, hearing some more popping noises inside the module. Again, that's a good sign, indicating that there's some motion inside. And for now, we go right back into our cycle of standing by, monitoring for any changes in the module shape, getting a final pressure reading, and then deciding the next steps. And so a quick handover of the satellites. We'll get that video comm back in just about a minute. And continuing to stand by, the video already coming back up, continuing to stand by while we wait for beam to settle after this last pulse of air. This again was the 7th time the valve has been open. And just before losing that video signal, the robo reporting that the length now out to 20.5 inches, so another 2-inch gain over with that last 3-second burst of air. The inner diameter now up to 120 inches, so getting closer to our bingo marks for the full expansion of beam. But again, this slow iterative process being done just to continuously monitor how the module is expanding, and also, of course, doing it in a safe and conservative fashion, obviously to protect any loads that could be imparted on the station itself. But this slow gradual process continuing this morning, again continuing to see motion in beam, continuing to see this expansion, and continuing to march towards that full size expandable module.
Yeah, Tim, we see that you have a CVIS session coming up here, and we wanted to remind you that it is okay for you to proceed with CVIS during beam operations. It's just T2 and, of course, ARED and then Bay Day 2 that we cannot have performed during beam, but CVIS and VALO are fine.
Okay, thanks for the reminder. I appreciate it.
You're welcome.
Good morning and welcome to Mission Control Houston and Space Station Live. The new beam.
And then we'll have to stand down the operations one more time with another gap, and then we'll resume our coverage as well just shortly before the video comes back up. Currently expected to be at around 11:14 a.m. Central Time, so we'll have about a 30-minute gap or so. And then the teams will get one more opportunity, one more good pass of coverage. We are continuing to stand by while beam settles out after this last opening of the valve. Again, it came at 10:24 a.m. Central, so just about 10 minutes ago. The valve was open for 3 seconds, giving us an increase of about 2 inches in length in beam, and then another 5 inches to the internal diameter that the teams now have good eyes on. And the calculations once again being run, combining the pressure and then the volume of beam calculated from that length and diameter to come up with a good number for the valve to be opened up on the next run. We've had the valve open 7 times so far for a total of 48 seconds. And beam continuing to expand along so far this morning. Just a reminder, we do have another gap in that video coverage with the International Space Station coming up in just about 7 minutes from now. So once that occurs, they'll again stand down operations until it resumes, and we'll break away from our coverage for about 30 minutes or so, and then resume just shortly before the operations pick up again. But for right now, continuing to stand by, hopefully getting some responses from the engineering teams doing the analysis in the next minute or so, and then able to hopefully give Jeff Williams another number to open up that valve, put more air into beam, and continue along with this expansion process. Continuing to stand by for just a few minutes until this next value is calculated and Jeff Williams gets ready to open up the valve once again. It's been opened 7 times so far, a total of 43 seconds so far this morning. That first one coming at 8:04 a.m. Central Time. The most recent, just a little over 10 minutes ago at 10:24 a.m. Central. That last opening was for 3 seconds and increased the length another 2 inches out to 20.5 so far from the packed configuration to where we are now. And then the internal diameter calculated at about 120 inches. So the team's again looking at the volume, looking at the pressure readings inside beam, then coming up with a number to be radioed up to Jeff Williams standing by on board the station to open up the valve and resume these operations.
Okay, Jeff, you can give it a 1 second pulse, a 1 second pulse. Then we're going into a KU blockage, so we won't resume again until around 16:15.
Copy, 1 second. Pressure 16.8, now 7.
Okay, Jeff, any noise associated with that one?
Had a couple of random infrequent pops, but I would not say that it accelerated in frequency.
All right, copy that. So as we just said, we're going to have to wait until the next KU pass at 16:15. And just so you have some bigger picture, we think what's happening is that with each of these rip stitches, that's why we're kind of hanging up on those rip stitches. We know, we have the profile, we know when to expect those, and they are at about 22 inches right now, the next rip stitch, so we think we're upon another one there.
Okay, I understand. You want me to continue recording during this time? About 14 minutes left in this card.
Okay, copy. Yeah, you can turn it off for now. We don't need it during this period. Thanks, Jeff.
And so with that, the 8th opening of the valve, this time for 1 second again, giving us a total of 44 seconds of air flowing from station into beam so far this morning. That coming at 10:42 a.m. Central Time, 11:42 a.m. Eastern. As you heard Capcom Jessica Meir indicate, we are going to stand down operations once again, as we do have about a 20 to 30 minute gap in coverage until we reacquire video with the International Space Station. So we will once again also stand down and sign off on our broadcast for just a little while. We will resume at 11:10 a.m. Central Time, 12:10 p.m. Eastern Time. For one more go at getting beam expanded this morning. So the teams will reconvene and look at any changes in beam with that last 1 second pulse, take a pressure reading, and then pick up operations where we just left off. So with that, we're going to take a short break. Again, be sure to join us back in just a little while at 11:10 a.m. Central, 12:10 p.m. Eastern, and we'll resume operations to expand the Bigelow Expandable Activity Module one more time. So with that, we'll go ahead and sign off. This is Mission Control Houston. Greetings once more from Mission Control Houston, and welcome to our continuing coverage of the expansion of the Bigelow Expandable Activity Module, also known as BEAM. This is our third go-round today, as we will be getting the video communication back with the International Space Station in about 4 or 5 minutes from now, and be able to resume operations to hopefully get beam expanded today. This the second attempt. We had previously tried to get beam expanded on Thursday, then the team stood down after not seeing the expansion along the length and diameter along with the increased internal pressure that they were expecting. However, things going much better today so far. Beam already expanding an additional 16 inches in length and at least 7 inches in diameter. So getting some good feedback also from Jeff Williams on board, who's been hearing a series of pops indicating that the various stitches and ripstop straps inside are continuing to rip apart as the module expands out, and he'll be back inside of Tranquility in just a couple of minutes from now to hopefully resume putting more air into beam from a valve, connecting beam to the air supply inside of station inside the Tranquility module, and begin this expansion process once again. Things kicked off this morning with the manual inflation beginning with the first introduction of air at 8:04 a.m. Central Time, at which point the valve was open for just about 22 seconds, and that getting us back up to the volume of air essentially that was in the module back on Thursday. Remember that the module was depressurized on Friday afternoon in the hopes that releasing the pressure could release some of the tension, causing the friction between the soft goods layers that the engineering teams from NASA and Bigelow suspected were holding up, and the friction levels a little bit higher than predicted, resulting in the expansion not going exactly as planned, but getting some good motion so far this morning after that second introduction of air, which was for 8 seconds, able to get the module to begin expanding along both its lengthwise and diameter. All told today, the valve has been opened 8 times, total of 44 seconds of air flowing from Tranquility into the beam module, and then hopefully standing by in the next couple of minutes when we get this video comm back and getting some more air in and hopefully getting beam expanded out today.
Pulses. Was able to finish the crew or the food consolidation, and I can report on item Delta 8, the 2.0 CTB is serial number 4034. And then one other note, there was one food Bob found that was not on the list. It's Sierra 124 Borisenko Cruise Pacific menu. And I've got a temp soda node 1.
And thanks, Jeff. We got it. This was Holly, and Jessica's back with you now. Good to talk to you.
NASA astronaut Jeff Williams calling down a quick stowage update. He'll be again moving back over to Tranquility very shortly, where the teams will hopefully pick up with this expansion operation. Again, the voices that you're mostly going to be hearing today will be that of Jeff Williams himself, the NASA astronaut, one of the 6 crew members of Expedition 47, who back on Thursday and today is the hands, the eyes, and the ears on board the International Space Station for the teams down here on the ground to actually do all of this expansion operation. And now getting our look back at beam, and we can already see a pretty significant increase in size just from when we broke a little while ago. And so right now the robotics officer here in Houston will use the overlay that you're seeing on your screen to calculate just how far along beam is, and then using both the length and diameter, able to calculate a value, get a pressure reading from a multimeter that Jeff Williams will be switching on shortly, and then able to hopefully come up with a value of air that he'll be able to then introduce into beam.
And Houston station on 2. Current pressure is 14.1 and continue to get infrequent random pops.
Okay, copy all. Thanks for that info. Now that we have KU again, we're getting a good view, so it looks like we're still progressing. We'll be back with you after we assess a bit further.
We had a nice little burst of pops here. I'll turn the audio on for you.
All right, copy. We can hear that, Jeff. Thank you.
And again, getting a little bit of audio from inside the Tranquility module where, again, you'll hear some of these audible pops, and those are good noises, those are expected noises, and are just indicating that some of the stitching, some of the other straps inside a beam that were in place to then be ripped as it expanded are in fact ripping. So getting some good noises from inside, indicating some continued expansion of the module. And again, all told today, the valve has been opened 8 times, 44 seconds of air flowing from station into beam, and now the team's converging. We should be getting a number hopefully soon radioed up to Jeff Williams on board and begin to commence once again with the expansion operations of beam. So seeing about 6 inches increase in length over just that loss of signal with the video comm. We went from 22 to about 28, so seeing a good uptick and getting the pressure readings as well from on board. So we should be getting that number soon, hopefully, and then commencing with the expansion operations.
All right, Jeff, that's good news. We are seeing some good progress, as you can probably see with that VC uplink as well. We've had quite a bit of axial displacement now, so we are encouraged by that. But we're going to probably need about 5 to 10 minutes to really assess things on the ground and determine what our next input will be.
Copy. I'll be standing by.
And so you just heard Capcom and NASA astronaut Jess Kamir radio up. It'll be about 5 to 10 minutes for the teams to finalize their analysis down here on the ground. Again, seeing a good increase in the length along the axial, as you'll hear it referred to, distance. So out to 28 inches. Again, the magical number that we're trying to get to is 68 inches increase today. So well on our way at this point, and then hopefully getting a nice good burst of air in this next opening of the valve, and then continuing beam on its way. So we'll stand by for just a couple of minutes now while the teams finish out their analysis, and then wait for that call up to Jeff to once again open the valve, put some more air into beam, and resume operations. And so again, continuing to stand by, should be getting a call soon.
Okay, Jeff, you have a go for another 2-second pulse. That's 2 seconds. Station Houston on 2 for Jeff. We're ready for another pulse. This pulse will be 4 seconds. Disregard the previous call. This pulse will be 4 seconds.
Copy, 4-second pulse.
And so Jeff Williams getting the call, another pulse, 4 seconds. This will be the 9th time the valve has been opened today. Do a quick cycle there, get the multimeter up. That's giving the pressure readings inside that the teams are looking at. This go around will be 4 seconds to introduce another 4 seconds of air into beam. Here we go. Once again, this audio inside the Tranquility module, getting to hear some of those audible pops that Williams is hearing. That 4 second pulse of air coming at 11:28 a.m. Central. That was the 9th time the valve has been opened, so a total of 48 seconds of air now transferred over into beam. And we will once again stand by, wait to see any changes in the shape of beam, and then monitor the pressure, and then plot out the next steps from there. And we'll just continue to stand by. We'll next look for that first length and diameter reading from the robotics officer here in Houston. At which point, again, all of the engineers from NASA and Bigelow Aerospace down in the mission evaluation room with the MUR will run the numbers again and come up with the next amount of time that the valve can be open. Again, all of this being done in a very gradual, very incremental process, just to make sure that the expansion of beam is done in a safe and orderly fashion, not wanting to impart any excess loads back into the station from the expansion process. Also, obviously, the team's learning a lot on how to expand these modules with this gradual process, something that will be very valuable for any future expandable modules in a human spaceflight environment where you're doing the slow transfer of air from one vehicle to another. And so the robotics officer just sharing the latest values on beam size. It looks like the length is out now to 30.5 inches from the pack configuration, so an addition of about 2.5 from that last 4-second burst of air. The diameter decreased down to 118, but this was expected as the shape of the module will change, flattening out a little bit as it continues to elongate. The end diameter will be 127 inches. The total length addition that we're looking for is at least 68. It'll eventually go out to 73 for a total length of 158 inches. So getting a little bit more increase in size with this last burst of air. And now the teams will again all gather, assess, and come up with the value for the next opening of the valve. So we'll just stand by for a few minutes and await that decision.
All right, Jeff, we're ready for one more second. That's 1 second.
Copy, 1 second. Pressure is 13.8 and no immediate response.
Houston copies.
And so Williams putting in one more second of air. That the 10th time the valve has been opened, a total of 49 seconds. The air has been flowing from Tranquility into Beam this morning. And again, right back into our cycle. The teams will now look for any changes in the shape. They'll look at the pressure, then come up with an amount of time for Williams to open the valve once again. So rinse and repeat with beam expansion. Again, a very gradual process, but things moving along well so far this morning. A little slower than predicted, but seeing good expansion so far. A pretty significant increase in beam size evident just from these camera views. So continuing to march along with expansion today. And getting the updated numbers from the robotics officer, the length now increased out to 32 inches, so another inch and a half since the previous burst of air. Diameter holding steady at 118 inches. Again, just the final numbers we'll be looking for. The diameter will be out to 127, but the key number we're looking for is along the length, where we'll look for a beam to expand out to 68 inches. So at 32 right now, 68 the number we need to get to before the actual pressurization of the module can occur. And that pressurization will be the fifth and final step for today, and that will involve opening up the 8 air tanks located inside of the beam module to allow it to bring it up to the same atmospheric pressure as the rest of the station, which will then kick off about a week of leak checks and other analysis of the module before the first ingress, the first time the crew members can go inside. So again, seeing another increase in size in beam. This it's a slow and incremental process, but continuing to get results from putting air in through this valve, and should hopefully be getting a new number up to Jeff Williams soon to once again open the valve and continue on with this operation.
Jeff, you have a go for 2 more seconds. That's 2 seconds.
Copy, 2 seconds.
Williams once more at the hatch in tranquility. Another 2 seconds about to be opened for the valve. So we'll stand by, watch him flip it open, and then look for motion again. Here we go.
Sure, 14.1.
And so we'll continue to monitor for a little bit of motion, see if beam continues to expand out a little bit more. That, again, the 11th time the valve has been opened, 51 total seconds now of air flowing from station into beam. That coming at 11:43 a.m. Central Time.
All right, Jeff, we think we're probably approaching another one of those rip stitches here. So we'll go for one more second. 1 second.
Be 1 second.
And so Jeff Williams getting the call. Another 1 second pulse of air. This one at 11:46 a.m. Central. At the 12th time the valve was open. 52 seconds total now. Air flowing from station into beam. The robotics officer reporting no appreciable increase in either length or diameter after that previous one.
Okay, good to know. Thanks, Jeff.
And so before this last pulse, we were still at about 32 inches in length, 118 inches in diameter. And we'll stand by, see if there's any changes in beam shape while the evaluation teams again meet and come up with our next value for valve opening. But we'll stand by. Again, things continuing to progress a little bit quicker now as we're getting air into beam a little bit faster than we had through the previous two passes earlier this morning. So we'll stand by and wait for that next value and see if there's any changes in beam's dimensions, and then update you shortly. And the robotics officer reporting that last burst got us another 2 inches in length, diameter holding steady at 118 inches. So seeing some more movement with beam, should be getting the call up for the next burst of air shortly from the engineering teams. Again, both NASA and Bigelow Aerospace working together to calculate these values, which are then passed up from Capcom Jessica Meir up to Jeff Williams on board the station, who's been manually operating the valve. And a quick data point now that we have increased 34 inches from that packed configuration. We're halfway to that magic number of 68.
Jeff, we're ready for another 2 seconds. That's 2 seconds.
Be 2 seconds. Fourteen decimal zero.
We copy.
And so Jeff Williams giving it another 2 seconds That coming just at about 11:50 a.m. Central Time. That was the 13th time the valve's been opened. 54 seconds total air flowing from station into beam. And once again, I'm going to wait and look, see if we get any more length increases. The diameter's been holding pretty steady at 118 inches. It'll eventually be up to 127, and we're halfway, hopefully more after this pulse, on our way to 68 inches, at which point the manual inflation period will be complete. We'll be able to move over into expansion or pressurization. We'll continue to stand by until we get those readings from Robo on any changes in beam shape. Just to update you on comm though, we don't really have any of those big gaps that we were dealing with in the start of operation, so we should have pretty solid video comm with the station from here on out through the end of crew day. So things looking good to continue, and hopefully get beam fully expanded over these next passes just now. But things progressing smoothly so far. Been able to do a series of bursts of air into beam over the last 30 minutes or so. And the robotics officer reporting things pretty much look the same after that last impulse of air, still at 34 inches, increase in length, total diameter 118. So we'll stand by now, let the evaluation teams come up with the next step, the next amount of air, and we should be getting that shortly. And a short handover period will get this video come back very, very quickly. But where we're reporting we might have gotten about another ½ inch or so along the length. So the team's again conferring, putting in all the numbers into their calculations, and then coming out with that next value for how much air they're going to be able to put into beam. So again, just continuing to stand by a few minutes. The call is definitely coming a lot quicker now. Should hopefully get another opening of the valve momentarily. And so again, just continuing to stand by for a few minutes. The team's running the numbers, looking at the pressure reading, the length and diameter of beam so far. Again, we just finished that last burst of air. It was the 13th time the valve had been opened, and it was for 2 seconds. So a total of 54 seconds of air running now into beam from station. We're sitting right now at an increase of about 34.5 inches along the axial range, so lengthwise. And diameter is pretty much held steady at 118.
Jeff, we're just wondering if you're still hearing any of those popping noises.
Very infrequent and random. But yes, continuing.
Okay, we copy. Thank you.
And continuing to hear infrequent random pops.
We copy, Jeff. Thank you.
Jeff Williams reporting. Still continuing to hear a few pops. Meanwhile, the team's down here on the ground waiting for the pressure to settle out a little bit. Not seeing a great deal of increase.
Something interesting for yourself there, Jeff, while we're waiting in between these.
Well, I confess I am getting some other work done.
So just to fill you in, Jeff, we're just waiting for a little bit more of a pressure decrease before we can go with more successive bursts. So if we can get down a little bit lower, we'll be able to resume.
Copy.
And again, as you just heard, Capcom just come here, radio up to the station. The team's just waiting for the pressure to settle out a little bit more. Should just be another 0.1 or so on the multimeter there until we're ready to resume with another opening of the valve. So just standing by for a few more minutes until that pressure settles out, and then we'll be able to pick back up and begin putting some more air back into beam. So it's looking like the pressure is starting to settle. We should be getting that call up soon, hopefully, to once again open the valve. It's been opened 13 times so far throughout the operations today, a total of 54 seconds of air flowing from station into beam. Should be getting that next one and the next call up to open up the valve once again shortly.
All right, Jeff, we are ready for a big 1 second burst here. 1 second.
One second. .13.8.
We copy. We have a good view of the multimeter.
And so another valve open, another 1 second of air flowing into beam. The 14th time, 55 seconds total since operations began this morning at 8:04 a.m. Central Time. And so now we'll once again wait and see if beam's shape changes at all, looking again for those increases in length. The diameter has pretty much been holding steady, but will eventually begin expanding out again as well. So good news from Robo, starting to see some increases again in beam size, up to 35 inches now in length from that original packed configuration and diameter just eked up a little bit more to 119 inches. So that 1 second pulse that just happened at 12:12 p.m. Central Time, adding in a little bit more size to beam shape. So we'll wait and see what the pressure comes out to be, and then again the teams will configure their next value for opening up the valve while taking a look at those numbers from Robo. We should be hopefully getting those calls a little bit more quickly like we were doing earlier.
I continue to get random infrequent pops.
Okay, we copy that. Thanks, Jeff. We're looking for another pressure decrease before we resume again.
Copy.
So we're in another wait and hold moment. Again, just waiting for beam to settle out a little bit, the pressure to come down a little bit before we can once again add in some more air.
Okay, Jeff, another lavish 1 second. That's 1 second.
Copy, 1 second.
And so with that, the valve opened for the 15th time, another 1 second pulse.
.13.8.
Copy.
And again, that the 15th time the valve has been open now today. Total of 56 seconds of air flowing from station into beam. So now we'll stand by, see where the pressure ends up settling, and if we get any more motion or any more increase in the length and diameter of the module, which is again continued to slowly expand throughout this incremental process. We're looking to get the increase in length out to 68 inches before we can start the pressurization phase of the deployment operations. So we're more than halfway there. We'll continue along. Should have good video communication with the station throughout the rest of the operations today. No more big gaps staring us down. So should be good to go for a while yet. Jeff Williams continuing to work inside of the Tranquility module. The team's down here on the ground, once again looking at the numbers, waiting for Robo to call out any changes that she's seen through the overlay graph, using that view from the very tip of the robotic arm, which has been pointed straight at beam for the last several days. And so we'll once again stand by for a few minutes until we get our next call. so robo reporting, we did see another increase in beams length along the axial line out to 37 inches now, so about an inch, inch and a half from the previous increase. Diameter holding at 119. So once more in a bit of a holding pattern while we wait for the pressure to settle out, looking like beam starting to orient its path down the axial line a little bit more, which is why we're seeing these slightly lower increases in the length, but out to 37 inches now. Again, need to get out to 68 before pressurization can begin. So things progressing a little slowly, but definitely progressing today as we continue to add air into beam. The valve has been opened so far 15 times by NASA astronaut Jeff Williams. Total of 56 seconds of that valve being open to allow air to flow from station into the expandable module. So we'll stand by once more for a few more minutes, let the pressure settle down, and then the evaluation teams will come up with another number for Jeff to once again open up the valve and allow more air to go into the module. So again, just standing by. We'll get back to you shortly. And just to update you quickly, we're continuing to stand by, again waiting for that pressure to settle out a little bit. The last call from Robo indicating that beam has so far traveled 37 inches beyond its original pack configuration in length. The diameter holding at about 119 inches. So everything continuing to progress today with the operations. We'll stand by the teams from NASA and Bigelow Aerospace wanting the pressure to go down just a little bit more before we once again open up the valve and get some more air from station traveling into beam. So we'll continue to stand by.
Houston, you expect to hold here until the other side of this LOS?
We're not sure, Jeff. We'll get back to you on that.
Okay, standing by.
And so it looks like we will enter into a short gap of communication with the station. So we'll, as usual, have to wait until we reacquire that video and audio communication. This will be a much shorter one than we experienced earlier, though, only about 6 minutes or so. We should get this comm back by about 12:50 p.m. Central Time, and it'll lock back up and be solid to once again resume operations. But for now, we are still standing by. Again, the pressure inside of Beam needed to settle out a little bit more before the teams were ready to add in any more air. And so this gap should hopefully allow us to get down to that pressure, maybe even see potential increase in the size of Beam. As we've seen over previous gaps, those were much longer, but the module definitely seeming to continue to expand over time. I do want to thank you for sticking with us so far this morning. It's been a slow and gradual process. The valve opened 15 times for a total of 56 seconds of air. Things kicked off at 8:04 a.m. Central Time, so we sit here a few hours later, but Beam continuing to expand out today. So we're seeing much more motion than we saw during that first attempt on Thursday. The module more than halfway to its goal of 68 inches additional in length from the packed configuration of just about 80 inches. And so again, that final length is going to be 158 once it expands out the full 73, and that's all following the pressurization and everything else. But 68 is that bingo mark that we need to get to before the pressurization step can begin, and those air canisters inside of Beam can open up to pressurize it to the same levels as the station itself. So again, this has been a very slow and iterative process, but it's going to continue, and we will
All right, Jeff, you're
get
for
Beam
a
deployed.
1 second burst. 1 second.
And just there, Jessica Meir giving Jeff Williams the go-ahead for another 1 second pulse of air.
1 minute, 20 seconds to an LOS.
Thirteen decimal 8, no 13.7, no apparent response.
Copy.
As soon as I say that, I get a pop, one pop.
Okay, copy.
And Jeff Williams getting the chance for one more opening of the valve before we go into this short loss of video comm with the station. Again, we'll pick this back up in just about 4 minutes and be able to hopefully resume operations once again. That was the 16th time Williams has cycled the valve open. This another 1 second opening, giving us a total of 57 seconds of time with air flowing from station into beam. Again, everything kicked off at 8:04 a.m. Central Time this morning. That pulse coming at 12:45 p.m. Central Time as we continue this operation to expand Beam, the Bigelow Expandable Activity Module, the first human-rated expandable module ever to be flown into space. A very slow process to get this expanded, as there are a lot of conservative procedures in place, again, just to make sure that the expansion process is done in a very safe and orderly fashion. And of course, the team's learning a lot just by going through this process on how to expand these modules in space, especially in that human space flight environment with humans in the loop. So everything definitely a learning experience, as this is a technology demonstration, but things progressing, and we'll pick up back with this video comm in just a couple of minutes. And again, for those continuing to follow along, you're getting a look inside the International Space Station Flight Control Room. We'll be getting our video communication signal back with the International Space Station momentarily. And we are still in the midst of expanding beam. Jeff Williams on board just introduced another 1 second pulse of air at 12:45 p.m. Central. That the 16th time the valve has been opened so far this morning. And once we get this comm back, the robotics officer will once again look for any increases in beam's shape, looking for another increase in length and diameter. The most recent number was 37 inches. Again, we're more than halfway now to that 68-inch point at which we can begin the pressurization process of beam. So continuing to move along. And once we get those numbers, the teams here, again, once in mission control and in the support rooms from NASA and Bigelow Aerospace, will come up with another number, radio it up to Jeff Williams, and we'll continue moving along. So again, thanks for sticking with us throughout the day today as we continue with this process. Again, this is the first time we've ever tried to do this type of operation, so obviously going to be a learning process for all of the teams in the operations, but things continuing to progress along today. And Beam continuing to increase in size. Again, we're more than halfway there, and hopefully just a little bit longer today. And we do have that video back. As you can see, you're looking at the robotic overlay that the robotics officer here in Houston's been using to give these call outs and track the progress of Beam during this expansion process. Again, if you're able to get close to your screen and look at that grid, and you can look over on the 70 hash mark, it's towards the right of this grid. You'll see two lines around it. That orange line just to the left of it is the 68-inch mark that we need to get to before the pressurization can occur. And then the line just beyond 70 is 73, and that'll be the final length. And just now the robotics officer doing the quick calculations and confirming that Beam did expand a little bit more with that last 1 second pulse out to 38.5 inches, so another 1.5 inches with the most recent pulse that went in at 12:45 p.m. Central. Diameter up another inch to 120 inches. Again, the final diameter is going to be 127. So continuing to see some movement. The evaluation team's now going to plug those into their calculations and come out with another number for Jeff Williams to open up the valve. So we're once again in our holding pattern. We'll stand by for a few moments. And so once again, you're getting some of the audio from inside the Tranquility module. That's what Jeff Williams is hearing, and you'll hear those occasional pops, and those again are expected and good noises. In fact, that they basically signify that beam's continuing to expand outward. Pressure just about at the point where we'll be able to put more air into beam, so should be getting the call hopefully in the next minute or two once that settles out to once again open up the valve. And again, you were just listening to just some ambient sound inside of Tranquility Node 3 to which beam's attached. You do hear the occasional popping sounds, those coming from inside the Bigelow Expandable Activity Module. Again, those expected sounds basically just indicating that the module is continuing to creep out, continuing to expand. At the last call, Robo had indicated we were at about 38.5 inches increase in length, 120 inches total in diameter. And so all told 16 times the valve's been opened today by Jeff Williams. We'll stand by for just a little bit more while we continue to wait for the pressure. Looks like it's just starting to get to that point where we will be able to once again open up the valve and get some more air into beam and hopefully move things along.
Okay, Jeff, if you're still with us, we're ready for one more second. That's one more second.
I didn't go far. One more second.
Williams moving into tranquility now for the 17th opening of the valve. There we go. And one more second of air now flowing into beam. And again, with that, the valve now opens 17 times, a total of 58 seconds, so almost at a minute, a full minute of air flowing from station into beam. We'll now wait once more for the module to settle out and robo to hopefully see some increase along the axial, along the length, and also get a diameter reading for the engineering teams to once again evaluate. We'll probably have to wait for the pressure to settle out again, so we'll stand by for another couple of minutes. But again, the 17th time we've opened up the valve, it being opened at 1:07 p.m. Central. Again, we kicked off today's deployment operations at 8:04 a.m. But Williams just opening it up, moving things once more, and we'll now stand by and wait to see if we get any increase in size in the expandable module. And so we're standing by. We should be getting any changes in the length and diameter from the robotics officer soon. Again, the last pulse of air for 1 second coming at 1:07 p.m. Central, 2:07 p.m. Eastern Time. That was the 17th time that Williams cycled the valve, allowing air to flow from station into beam. And Robo reporting that that last pulse of air did buy us another inch, so up to 39.5 inches. Diameter holding steady at 120. So with the recent call from Robo, again, we're at 39.5 inches in length from the packed configuration, 120 inches in diameter at this point. We will still need, again, to stand by and wait for the pressure to settle down a little bit, about 0.2 millimeters of mercury more, until they'll be able to once again open up the valve and introduce more air into beam. The next key number we really need to get across is about 40 inches, at which point they'll again be able to operate at a little bit higher pressures, and those numbers will start coming in a little bit quicker. But for now, we are still in this kind of sit and wait scenario where we'll have to wait for the pressure to settle down. It's typically taking about 15 minutes or so right now in order for that to happen. So we'll stand by a little bit. Again, it's been about 10 minutes since the last pulse of air at 1:07 p.m. So hopefully in another 5 to 10 minutes should be able to have had that pressure settle down, and then Jeff Williams will once again be able to open it up, hopefully get us beyond that 40-inch of expansion in length, and then be able to pick up hopefully a little bit quicker, again pressing out to that eventual 68-inch mark. That's what we're all really looking for today, so they can begin the pressurization phase of the Bigelow module.
And we're continuing to get random, infrequent pops.
Okay, copy that. Thanks, Jeff. We're still waiting for another pressure decrease before we give another burst.
The team's continuing to stand by, again, waiting for that pressure to settle out a little bit more. And once it gets down to the right value, they'll be able to, once again, open up the valve and get things moving along. But for now, we are still just in this kind of holding pattern, waiting for the pressure to settle out, as we're not seeing any more movement in the structure of beam itself. So we're just continuing to stand by, and again, as soon as we get any updates, we'll continue to bring them. But for now, just standing by. And this is Mission Control Houston. A quick handover now. We'll get that video communication back with the station momentarily. But again, still waiting for that pressure to settle out. The team should hopefully be close to giving the go-ahead for Jeff Williams to once again open up the valve. It's been about 25 minutes or so since the last time that he was able to cycle the valve for just 1 second, getting another pulse of air into beam. Again, right now we're sitting at 39.5 inches increased length from that packed configuration, needing to get out to 68 by the end of crew day in order to do the pressurization steps as well. Diameter holding steady at 120. It'll eventually expand out to 127, but that length increase, that 39.5, needing to get out to 68, really the number that we're paying attention to. And then the pressure needing to settle down a little bit before they can open the valve back up. Again, the team's following all of their predetermined models on expanding beam, all of these done with some conservatisms built into them, some cautions, as of course, as we're doing this for the first time ever, we want to be very sure that we're not imparting any loads back on station or, again, putting the vehicle or the crew at any risk. So that's why it's been this very slow, very methodical process throughout the day, and just as it was before things stood down back on Thursday, this very much a learning experience, not only for NASA, but also Bigelow Aerospace, the company that built, designed, and manufactured Beam, and got it to where it is right now attached to the Tranquility module. So we'll just stand by. We should, again, hopefully be getting that call up in the not too distant future to once again open up this valve for Jeff Williams, who will be back in Tranquility, and hopefully get another second of air or so into Beam.
Okay, Jeff, we're ready for 1 more second, please. 1 more second.
Be 1 second.
And we just saw Jeff Williams open up the valve for the 18th time. 1 more second of air flowing from station into Beam. We're at a total of 59 seconds now that that's been open, just shy of 1 minute.
And currently everything is quiet.
Copy, Jeff.
Now we got some pops.
Copy.
And so once again, in that monitoring posture, waiting to see if there's any changes in beam shape. The robotics officer will look closely at the overlay, monitor that, and see what the length and diameter get out to. Again, that last 1 second burst coming at 1:35 p.m. Central Time, another 1 second, bringing us to a total of 59 seconds total of air flowing from station itself over to the Bigelow Expandable Activity Module. We will wait and see how the numbers line up, hopefully get out of this longer cycle of waiting for the pressure to drop down and equalize a little bit, or not equalize, but just drop down to a more acceptable value. But we will once again go into this standby posture, waiting for the call from Robo, update you on those numbers, and then listen for the latest update from the evaluation teams, the NASA and Bigelow Aerospace teams that are doing all the calculations to then get a number up to Jeff Williams to open up the valve. So we'll go ahead and stand by again. Thanks for following along with this beam operation today. As again, this is the first time we've ever done something like this, so definitely a learning process for all of the teams, from operations to simulation to modeling, all together working to get this module expanded safely, first and foremost, but also get it expanded out successfully. So we'll stand by and wait and see, and then we'll update you shortly. So we're continuing to stand by here in Mission Control Houston. The team's discussing forward options. Robo did call in the latest values for beam dimensions. We are now at 40 inches in length increase. And then that coupled with the 120-inch diameter, still putting us at pretty much the same situation we've been on for the last little while on this safe pressure curve, where we need to wait for the pressure to come down a little bit still in order to give Jeff Williams the go-ahead to open up this valve again. So the team's discussing their forward options, as the crew does have a finite workday. So they're gonna start looking at the options for the rest of the afternoon and what's available to them, and then decide what we're gonna do going forward. But for now, just standing by for the pressure to settle out once more. The team's all discussing, and we'll update you shortly.
Okay, Jeff, thanks for your patience with this. We're ready for 2 seconds. That's a 2-second burst.
Copy. 2 seconds coming up.
And operations resuming. Capcom Jessica Meir giving Jeff Williams the go-ahead for 2 more seconds. This will be the 19th time it's been open today, and will push us over the 1-minute mark of total time air flowing from station into beam.
Working point 2 and quiet on the other side.
Okay, copy, Jeff. And just so you understand, I think you, as we talked about last time, we're really playing against those safe pressure curves. So that's why we're waiting in between each one and keep looking at that pressure.
Okay, yeah, I understand. We all talked about what the rest of the day's plan might look like. In other words, where do we need to get to today to get to a safe config?
Yeah, Jeff, we've been talking that down here, and just so you know, we will not need to perform those depress activities. So you can assume that those are off your timeline for the day. At this point, we just need to decide where we're going to stop, how far we're going to go into your crew day, and if we don't get this fully deployed today, then when we'll pick up. But we are in a safe config right now.
Okay. We're in a config with constraints, though, correct?
Actually, no. At this point, the exercise constraint will be lifted, so you guys will be free to exercise tomorrow, and even in this config that we're currently in.
I understand. That's good. And we'll be finishing up tomorrow, whatever we don't get done today, in terms of the pressurization.
Yep, it's looking that way. We would, if we don't finish today, then we would resume with the inflation, complete that, and then also perform the pressurization.
Okay, I understand. Thanks.
And then our plan would be to give you most of Monday off to recoup that time.
Yeah, I'm not worried about that. I'm just wanted to understand what your thinking was, and I'm happy to go as long as you all want to this afternoon.
Okay, thanks for that, Jeff. We appreciate it.
And so as we just heard in that discussion, the team's now obviously paying attention to the end of the crew day for Jeff Williams for just how long we'll go. But in the event that the team's not able to get beam fully expanded and pressurized today, it is looking like we'll be picking up those operations tomorrow on Sunday. But again, we'll confirm that, and also look to get any potential times that would occur, again, in the event that we aren't able to finish up today, as we are running into the end of Jeff Williams' crew day today. But we'll continue to monitor and listen in with the teams. We are still standing by for the latest calls on any changes in shape from the robotics officer here in Houston, any changes in shape of beam that they'll again get from that overlay. So we'll stand by for those, and then again update you on any of the decisions that come out if and when the teams do decide to stand down on expansion operations today, and if so, when they would pick up tomorrow, which is looking like the most likely option. So we'll stand by, update you shortly. But again, the last pulse going in at 1:53 p.m. Central Time, so just about 5 minutes ago. That was a 2-second pulse, and that was the 19th time that Jeff Williams cycled the valve. And we've now had 1 minute, 1 second of that valve being open and air flowing from station into beam, and we'll get those measurement updates shortly.
And Jeff, for all of you guys, just to make sure that you understand the exercise constraints. So as I mentioned, we are in a safe config, so you guys are free to do any type of exercise when we're not doing this manual inflation. So for example, if we pick up tomorrow during orbit 2, on orbit 1, when we're not doing any manual inflation, you could do any type of exercise. However, once we resume with the dynamic inputs, then we would once again be up against those constraints for ARED, Bayday 2, and T2.
Okay, yeah, I understand. How about the Velo, the fixed Russian cycle ergometer?
Yep, both Cevis and Velo are fine during any of these activities.
Okay. We thought only Cevis was clear.
No, both Cevis and Velo, and so we believe the Russians replaced their Bayday 2 scheduled exercise this afternoon with Velo.
Okay.
And those numbers just came in from the robotics officer. The axial displacement, or the increase in length, now at 40.5 inches. So beyond that 40 mark, so hopefully should be picking up with the frequency that we're able to open up the valve, the diameter holding steady at 120 inches. And this is Mission Control Houston. Again, we're just in this holding pattern, waiting for the pressure to come down a little bit. The team's discussing forward steps, just how long we're going to continue the expansion operations today. As again, as you had heard a little bit earlier, we are getting towards the end of the crew day today. Jeff Williams has been sticking around for the last 6 hours or so to do all of these manual inflation operations on beam today. All told, he's opened the valve 19 times since the first one at 8:04 a.m. Central Time this morning. The most recent coming at 1:53 p.m. Central, where he gave it a quick 2-second burst, which pushed us up to 1 minute and 1 second total time of air flowing from station into beam. And for now, the teams, both the ops teams here in Mission Control and all of the engineering evaluation teams from NASA and Bigelow Aerospace, discussing what our operations are going to look for the rest of the afternoon, and basically where we'll leave off and then pick up looking like tomorrow on Sunday. And again, we'll look for, if we do stand down from operations today, when we will begin on Sunday. But don't have those times just yet. But as we heard, the Capcom Jessica Meir radio up beam in a safe configuration right now. Could be left in this configuration overnight at any point during the expansion process, and no impacts to the crew once we call off the operations, all of their no constraints on their exercise or other things like that, while we are out of the active procedure of adding air into the module. So we'll just stand by for a couple of minutes, hopefully getting some decisions shortly from the flight control team here in Houston, and then we'll update you as soon as those come across. And this is Mission Control Houston getting some good news from Robo. The length now out to 42 inches, so definitely a good thing to hear anytime we get some increase along the axial range for beam out. So 42 inches in length now from its original packed configuration. And for now, the teams will take that number into account and see if we'll be able to add any more air into beam anytime soon. And so we'll wait and stand by for that analysis to be done, along with, again, any of the next steps being discussed for just how long we're going to be continuing the operations today, which kicked off again at 8:04 a.m. Central Time, so just a little bit over 6 hours ago this morning. Jeff Williams has been working inside the Tranquility module to do all of these flips of the valve to introduce air into beam. He's done it 19 times so far, 1 minute, 1 second of air flowing from station into the expandable module. For now, we'll hold on for a few more minutes, wait until we get some more analysis out, and hopefully get some more decisions soon on just how long we're going to continue expansion operations today. And again, if we do decide to stand down on operations today, we will look for which times or at what time we will resume, looking most likely like tomorrow morning. So we'll update you on those data points as they come in. Just continue to stand by for a few more minutes.
This is Station Line 2. Are you ready for the WRS MRF turbidate?
Stand by, Tim. Affirm, Tim. We're ready for that.
Put it in work.
So again, the teams here in Mission Control just looking over the data. The robo did give a call out that the module has increased out to 42 inches, so a nice little increase. Again, always a good number to hear. So continuing to expand along a little slowly, but very deliberately with all of our operations so far today. And again, we are coming up towards the end of crew day, their pre-sleep period, and then their sleep period coming up quite soon. So the teams will be making some decisions for just how long to continue the expansion ops today momentarily. And then we'll also be looking at when we're going to resume the expansion of Beam. As mentioned before, it's in a stable configuration right now, so it could be left in its current configuration even overnight, much as we did after Thursday's attempt, where it was left pressurized overnight into Friday for the teams to review and also to allow Beam to settle. And we did see a fairly significant drop in pressure and an increase in the diameter of Beam in that overnight, allowing it to settle out. Again, all of the soft good layers, which have been showing what we believe is some increased friction between the various layers and in the various layers, which is possibly causing this whole expansion process to just unfold a little bit slower than all of the initial predictions. But again, this is the first time we've done something like this, so definitely important to make sure we do it in a gradual process, learning the entire time and all along the way with this, and learning a lot more about expandables throughout this entire Beam expansion process.
It'll be stowed back in the Node 3 port encode.
Houston copies.
And we are in another one of those handover periods. We should be getting that video link up with the station back in about 3 minutes or so, and then we'll once again have eyes on Beam. But again, standing by for some decision points out of the teams that should be coming down shortly. And then as soon as we get them here in the room, we'll be sure to share them with you on our live coverage here on NASA TV. So just standing by for a few more minutes, updates to come shortly.
Station Houston on 2 for Jeff.
Go ahead.
Yeah, just to give you a big picture of where we're going today, we do intend to keep going a little bit longer today since you're okay with that. So we're going to have something for you in the next few minutes here.
Okay, sounds good. And the multimeter had timed out. I recycle at 13.4 currently is the pressure.
Okay, we see that. Thank you. And do you hear any more noises?
Yeah, still getting infrequent popping.
Okay, copy. Thank you. Okay, Jeff, brace yourself for this one, but we're ready for 8 seconds. That's 8 seconds.
8 seconds. Coming up.
And Jeff Williams getting ready to turn the valve once again. This will be the 20th time. A big jump now, 8 seconds.
Did I get your audio signal? See the activity or hear the activity?
Yeah, thanks, Jeff. We hear that.
Yeah, thanks, Jeff. We hear that.
And so Jeff Williams opening it up again for 8 seconds this time around, and now getting some audio inside of Tranquility. Once again, you can hear the popping noises coming from inside Beam. That again, good noises, is that's the rip stitching going throughout the module, just indicating that we are once again expanding.
That gave it a little more persuasion. Yeah.
Somebody seems to be doing something now. And again, that last burst of air, the full 8 seconds, bringing us to 1 minute, 1 minute 9 seconds total of air flowing from station into Beam. Continuing to hear a lot of those popping noises. Exactly what we're looking for, is that means Beam is continuing to expand.
So
We'll see just how long it continues this motion. And then we'll get some updated readings from the robotics officer here in Mission Control Houston. But once again, things in motion, operations continuing, hopefully pushing us towards getting beam fully expanded today, but we'll see. But things once again moving along, so we'll stand by for a little bit, listen in as we listen in with what Jeff Williams is hearing inside Tranquility, and hopefully see where beam settles out after this latest burst of air, the 20th time the valve was cycled today. So let's listen in.
Sounds like what we've been waiting for all day.
We can hear that, Jeff. We're tracking and we're watching the pressure too. Looking good.
Some noise, that's why.
As you can see on your screen, getting some very good motion now. Beam really starting to expand out with that latest influx of air. And that bingo mark we're looking for is 68 inches, so definitely getting a lot closer now. Once we're at 68 inches in length, they'll be able to begin the pressurization step, but definitely moving along now. As you can see on the grid, we're definitely getting a lot closer to that 68-inch mark. Again, we'll wait for the official numbers from the robotics officer. Things continuing to look good.
And Jeff, for your essay, we're back in the stage pressure curve. We're liking the movement that we're seeing here, and the last drift stitch actually occurs around 60 inches, so maybe that's why we're slowing down now. We'll have more for you soon.
Okay, good news. See you in the back.
As you just heard, the team's well within those safe pressure curves now, so well within where all of the initial predictions had us. So definitely happy with this increased movement we saw after that last 8-second burst of air, which again, that came at 2:31 p.m. Central, 3:31 p.m. Eastern was the 20th time the to really get Beam moving today, and a really significant increase in size as we continue to inch out. The last ripstop strap, so the last major kind of strap that'll require another bump of pressure, occurs at 60 inches, and we'll be coming up on that hopefully shortly. But we'll wait again for the calls from Robo once Beam kind of settles in its motion, and then they'll come up with another value. But the pressure looking very good inside. Definitely a lot of motion after that last one, definitely where we were hoping to be. And so we'll see if we're able to, hopefully at this point, complete this expansion today. And so Robo just calling over to on the flight loop, now at 56 inches increase in length from the packed configuration. The diameter now sitting at a total of 123 inches. So both those numbers looking very good. Again, continuing to get much closer now to that 58 or 68 increase in overall length that we need to get to. So just that last burst of air adding about 14 inches to Beam's length, and the diameter going up another 3 inches, so definitely coming into the shape that we're expecting to see it at by the time that all of this manual inflation activity is completed. But again, things looking real good for the teams down here in mission control now. And once again Beam kind of settles out and stops this motion, we'll look at potentially opening up the valve. Even one more good pulse of air could do it, but we'll follow along with the teams here in Mission Control and update you, and continue to watch Beam as it pushes out and gets real close to the end of this manual inflation today.
All right, Jeff, here we go. We're ready for 10 seconds. That's 10 seconds.
Copy, 10 seconds.
Jeff, do you mind if I film you?
No, not at all. Please do.
And so just then Jeff Williams opening up the valve one more time for 10 seconds this time around. At the 21st time. Now 1 minute 19 seconds total air flown from station into Beam. Continuing to hear those pops. Again, this is just some ambient sound you're listening to from inside of Tranquility, where Jeff Williams is stationed for all of these operations. Those noises, the pops that we want to hear as the module continues to expand outwards. Robo just calling out the newest numbers. We've now increased 59 inches from the packed configuration, just 9 inches shy now of that magical number of 68 where we can begin pressurization. Again, expecting another ripstop strap at 60 inches. And then the diameter for beam now up to 125, and then it'll max out at 127. And again, just to make sure you're clear, we're going to continue to call out both the length that we've increased from packed and the diameter.
We're ready for another 14 seconds. 14 seconds. 14 seconds.
Copy. 14 seconds.
And a sizable 14 seconds now about to go into beam. And so all told, that brings us to 22 times the valve has been cycled, 1minute 33 seconds of air flowing from station into beam. Getting close, very close now to the end of that manual inflation. Again, at that last call, we had increased in length across the axial plane by 59 inches, looking to get out to 68. And that, again, is just the increase from the pack dimension of the length, the initial length being just about 85 inches. So by the time beam is out and is increased 73 inches, it'll be at 158 inches to try and clarify a little bit. And then the diameter, the other number that we're looking at radially, so if we're talking the length going left to right, the diameter we're measuring top to bottom is out to 125 inches. That'll max out at 127. So beam just about at its full size, its full shape, and things definitely moving along now with this expansion process. Robo just calling out the axial, so the length increase now at 63 inches. We're just 5 inches short now of that space where we can begin the pressurization. Diameter out to 127 inches, which is expected to be the full diameter of beam. Next call coming up soon.
Jeff, we're ready for 15 seconds. 15 seconds. 15 seconds.
Copy. 15 seconds.
And so with that, another 15 seconds of air moving across. That the 23rd time that Williams opened up the valve. So we're now at 1 minute 48 seconds total of air moving from station into beam. We'll stand by one more time for calls from Robo, but getting very close now to this full expansion. As we heard at the last one, we were at 63 inches addition in length, and then the overall diameter of beam up to 127. That expected to be roughly its full diameter. So again, getting very, very close now to this full expansion, and getting very close now to moving past this step 4 manual inflation step that we got to on Thursday and started in today and have almost completed, and then we'll be able to move into the 5th and final step, pressurization, opening up the air tanks and beam and getting this module pressurized. Again, beam just about in its final shape. We'll wait for those calls from Robo, but the module definitely getting very close now to where we'll be able to stop this manual inflation process and open up the tanks inside of beam to begin the pressurization. And that process should go much, much faster as those will just kind of rapidly open up. Beam will be in its full shape, and they'll just add in some additional air to pressurize. And Robo reporting now at 66 inches in added length since we began operations. Just 2 inches short now of where we need to get to.
Okay, Jeff, great news for you. We're going to give it 30 seconds, 30 seconds, and we're only 2 inches from the finish line in terms of axial displacement. We're at 66 of our 68 inches.
Copy, 30 seconds coming up.
And so the valve opened once again, this time for the longest single interval yet in all of our operations, keeping it open for 30 seconds. So this will be the 24th cycle, 24th time the valve has been opened. That'll bring us up to a total time of 2 minutes and 18 seconds. And again, as you heard from Capcom Jessica Meir, we are just 2 inches away from the finish line.
I should do it.
So we'll wait for the call from Robo, but we are just about at that magical number of 68, the increase in length, so from left to right, that as we're looking at beam, that we needed to get to before the pressurization could begin. The diameter of the module, which we're measuring from top to bottom on your screen here, has been holding at 127 inches, which is the anticipated max diameter. And so Robo letting us know we're at 66.5 inches, so just half an inch closer now. And we'll wait for the Ethos console to weigh in and then hopefully get an update on just how much air we can get to. And we're very close now to the full expansion of beam. Just a little bit more to go. Hopefully just a couple more seconds or just 1 or 2 more cycles of this air valve and we should be good to go. So again, we're just standing by for a moment while the teams look at just how much air we'll be able to introduce on the next go around to push beam over the finish line. We're at 66.5 inches increase in length from the packed configuration. Need to get to 68, so just an inch and a half to go. The module at its full 127 inch diameter, so top to bottom looking very good. Just an inch and a half to go on the right there. So we'll stand by for just a few more minutes. Again, once we get to this 68, they'll be able to open up the tanks inside of beam. There are 6 of these, or 8 of these rather, that will then pressurize the module. All of that setting up for the eventual first ingress following about a week of leak checks and other tests.
Jeff, could you give us another 9 seconds, please? That's 9 seconds.
Copy, 9 seconds.
And so with that, another 9 seconds of air passed through. That was the 25th time Jeff Williams has opened up the valve in today's operations. That gives us a total time of 2 minutes, 27 seconds of air flowing from the inside of the International Space Station over to beam to help expand it out. We'll now stand by and see if that puts us over the edge and gets us to that 68 mark. Robotics officer here in Houston reporting 67 inches. So just about 1 inch short of what's planned to be the point at which we can begin pressurization of beam. Again, we're maxed out on the diameter 127 inches. Looking for just about one more inch though in the length increase in beam.
And we're still getting a random pop here and there.
Okay, copy that, Jeff. So, Jeff, we're currently at an axial displacement of 67 inches out of our 68, so just one to go.
Okay, very good.
The team's down here running the numbers. And so the team's talking it over here in Mission Control Houston, but it looks like we might be very close to calling this manual inflation process complete, at which point we'll be able to step into pressurization. So again, just waiting for one final confirmation, but looking like we'll be able to call it good at 67 inches axial displacement or 67 inches increased length from that packed configuration, and looking like we'll be able to move into the pressurization step. So we'll wait for the call from Capcom Jessica Muir up to the station once they're done discussing. But looking very good here, looking like we might be able to move in away from step 4 and into step 5 and the final step of this activity today.
Okay, Jeff, we are declaring manual inflation complete at this point, so we need you to pick up in procedure 1.302, step 4.12 through 4.17.
You said 1.302, correct?
Yeah, that's the procedure you were in, 1.302 beam deployment. So it'll be 4.12 through the end of that procedure in the XCP, so 4.12 through 4.17.
Okay, maybe I called it up in the wrong place, because I got step 2 and then it jumps to step 5. So let me search Optimus a little bit more.
Yeah, in Optimus, this would be the beam manual inflation activity. That would give you the XCP version that you need.
Can you give me a time on Optimus for this activity you're after?
Yeah, Jeff, that was the activity that started at 1300.
Okay, yeah, that's the one I had up. I don't see. Say again the steps you want me to perform.
Step 4.12 through 4.17.
Okay, got it. Okay, the MPV is closed and equipment's powered off and the ISS sampling port is capped.
Okay, we copy all, Jeff. With that, so the rest of your day, we would like you to perform the next 4 activities, or the 4 short activities that start at 1500 on your timeline. And then we're going to defer the deployment and RWS teardown activities. So the last 2 in that block will be deferred, but we'll need you to do the next 4. They have XTP versions for all those. Let us know if you need more words or step numbers.
Okay, I'll work through them here.
And just to recap where we are right now, as you heard the Capcom here today, NASA astronaut Jessica Meir call up at 3:10 p.m. Central Time, marking the inflation steps complete, the manual inflation and expansion of beam completed. It got out to an additional distance, or an additional increased length of 67 inches, so just 1 inch shy of previously anticipated, but the team's able to determine that they are still ready to go with a nominal pressurization, so calling it complete and successful. Again, at 3:10 p.m. Central, it expanded 67 inches additionally in length from that packed configuration and is at its full diameter of 127 inches. And now Jeff Williams moving on with the pressurization steps. He's going to reset up that deployment controller that was used back on Thursday to execute the first 3 steps in this 5-step process. And that will initiate the automatic opening of 8 air tanks stored inside of beam to release a much larger amount of air into the atmosphere, or into the internal atmosphere inside of beam, and then get it up to close to the exact same pressure as the rest of the station, that 14.7 psi, in order to equalize and then ultimately set up for that eventual first ingress the first time the crew will go in, and they'll open the hatch, and that'll all be done after, of course, a series of leak checks and other items first.
Figure 5 will be applicable, but Figure 6 will not.
Say again the steps that I'm going to skip.
Sure thing. You'll skip 5.8 and 5.9, and in 5.10, Figure 5 is applicable, Figure 6 is not.
Okay, got it.
So here we see Jeff Williams firing up that beam deployment controller again, and that's going to be used to initiate the automatic pressurization, so that opening of those 8 air tanks. And again, right now, Jeff Williams going through the steps. He's going to be setting up that that deployment controller, which is going to be used for the next step in our process, which is going to be the pressurization of beam. The module, the internal pressure inside the module, much lower than it is inside the space station. Not a lot of pressure needed to actually get it out to this full expanded configuration in the grand scheme of things. So pressurization, the next step, and that'll be an important step ultimately leading to the module being able to be entered roughly about a week or so from now, depending on how they're able to re-timeline everything with the crew's schedule.
Houston Station, we've reviewed 6.2 to 6.8.
We copy, Jeff.
Are you good with power up?
Yes, Jeff, you have a go to proceed at 6.2 to subsequent.
There we see Jeff Williams powering up that deployment controller.
Jeff, if you could change the angle a little bit of either the deployment controller or the camera. We can't actually read the screen right now due to the glare. That's a good view. We can read it now. Thank you. Okay, Jeff, we can read that now, but we also need to see the pressure multimeter in the view. So if we can get a view where we can read both the multimeter and that deployment status, that would be perfect.
So right now, Jeff Williams inside Tranquility doing some creative camera work to get the teams here in Mission Control Houston the view they need to follow along. But again, he's got the controller set up now and powered on. We should be just a few steps away from initiating this automatic pressurization, the opening of 8 tanks that have been inside of Beam since it was packed and flown to the International Space Station. Those will release air to then pressurize the module, expected to be in a range right around the same pressure as the rest of the International Space Station, which is kept at about 14.7 psi. They do obviously have the option of adding in additional air from station itself if necessary, just to equalize the pressure, but should be good to go soon.
Trying to find that sweet spot that gives you the angle to not get the glare in the display.
The other thing we can do.
All right, Jeff, we're good with it where it is right now, as long as we can still see the multimeter. Perfect right there. And then just give us calls. We can almost read the deployment status, but if you can just call those to us, there should only be 2 changes, so it won't be a lot for you to read to us. And then with that, we'll also need you to confirm in step 5.10 that the beam deployment controller jumpers were configured for pressurization.
Beam deployment controller jumpers are configured for pressurization.
Okay, copy that. And now you have a go for step 6.10. That's the review the beam deployment monitoring table 2, and let us know when you've completed that.
Should just be a few moments away now from the initialization of pressurization. That'll be the last event we'll be looking to follow along with here on our broadcast coverage of beam expansion. Following that, Williams will have a couple of tasks, some leak checks, and other things before he heads off to bed, working a couple of extra hours overtime for us here today. But very excited to obviously get beam expanded out to its full size and now get it pressurized. And so we'll stand by for a few more moments until Jeff Williams is given the go to initiate this pressurization.
In Houston Station on 2, we have reviewed table 2.
Houston copies. Okay, Jeff, with that, we're ready to start the next activity. That's procedure 1.303, table 2. In the timeline, it was the beam DC run 3.
And so now Jeff Williams will...
Table 2 and 1.303. We didn't call it through Optimus. We called it through the link from 302. I think we're okay, though.
Concur. That's not XTP. That's fine.
And again, now Williams will pick up with the deployment controller It will first go through the same sequence it did on Thursday, where it'll go through those first 3 steps, and it will just confirm that all of those were done successfully. They've used a jumper, essentially, to bypass the 4th step, which was done manually. And then it'll move into this pressurization step. And so once we get to pressurization, you'll see ISV sequencing show up on that small LED right below deployment status, and that is expected to run for about 10 minutes or so.
Analog is 14.5 is what I would say.
Okay, copy that. With that, you have a go for 1.2.
1.2 and work.
And so now the
AVV sequence.
beam controller box going through its
Copy.
steps. That first one, AVV, the ascent vent valve sequencing, will be the first of these 3 steps, which were already completed successfully back on Thursday. So the AVV sequencing, the RSC sequencing, the restraint strap cut, and then the FBH sequencing, that's the forward bulkhead release. Again, all 3 of those were done back on Thursday, so the controller needs to go through all of these steps in sequence before it can get to the next one, so it'll just basically get success on each of these and then move on to the pressurization.
Copy.
FBH sequencing. FBH success, Fox.
Copy.
ISV sequencing.
And with that,
Jeff,
that should
be the initiation of our pressurization.
Copy. And we hear the pressurization.
We copy.
And so with that, pressurization of beam has begun at 3:34 p.m. Central Time. And again, this is expected to last about 10 minutes. You can see the pressure gauge when we give you the internal view in the lower left. It'll slowly climb up. Beam not really expected to change much in shape at this point. It may expand out to its final length of 158 inches. It's a few inches short of that right now, but we hit the mark that we needed to in order to finish the manual inflation and move towards this pressurization stage. So again, this is expected to run for about 10 minutes or so. And once again, Jeff Williams giving us some ambient noise inside of Tranquility.
Plus the 13 psi on the analog gauge.
Again, right now, 8 tanks inside of beam opened up, the pressurization commencing.
And look at 200 millimeters. 9 psi in the analog gauge.
Looks normal on the video. It's not. It's kind of.
I got audio going out.
Okay.
Coming through 300 millimeters. 9 psi. It sounds like pressurization is accelerating. That must be an additional tank.
So Jeff Williams continuing to call down, and you can see occasionally on the screen of the multimeter there as we get pressure readings coming up on 400, and that's in millimeters of mercury, one of the standards for measuring pressurization. That equates to about 7.7 psi. And again, we're looking to get it up as close as possible to 14.7, which typically equates to about 762 millimeters of mercury.
I remember after the 4 tanks, the opening sequence.
Yeah.
Right now the tanks have been open for about 3 minutes or so.
There's another one. I think that's the 4th. And there's an additional tank opening. Coming through 500 millimeters, 5 psi. A few of them that didn't pop earlier.
Yeah.
No wonder it didn't run it before. I mean, they just stopped popping at 600 millimeters of pressure.
Yeah.
600 millimeters. About 3 psi.
Pressure inside beam continuing to rise as the air in all 8 of those tanks continues to flow into the expandable module.
Big one.
Coming through 700 millimeters. About a little over 1 psi.
So now over 700 millimeters of mercury in pressurization, that equating to over 13.5 psi. Again, looking to get as close as possible to 14.7. It can definitely be tweaked either up or down using air release valves or the same valve we use to put air into beam.
And then we're going to go to 1.302 step 7 after that. And then I don't have to
At any time an anomalous situation occurs, power off, run away. Coming Coming through 760 millimeters and close to zero on the delta.
760.
But it's going to be different than.
Yeah, it's like 756.
Yeah.
And so there we can see we've at least hit the point at which beam is just at about the same pressure as station. Again, definitely some leeway to go either above or below, and the pressure can definitely be equalized before that hatch gets opened. But looking like still plenty of air in those 8 tanks inside of beam to get it pressurized. Should be wrapping up shortly. Tanks have been open for about 8 minutes, expected to last about 10 minutes or so.
Pressure 791.
Copy.
So for right now, the pressure inside beam continuing to inch up for a little bit longer. Again, we're just at about 10 minutes since the tank's open, so this procedure should be ending soon. Definitely more than enough air now inside a beam to keep it at to get it to an even pressure with that inside of the station.
And we're coming through 11 minutes and 30 seconds and still have ISV sequencing.
We copy.
ISV success, Fox.
We copy.
EDC complete. Ready, light is out.
Houston copies.
And so with that, the pressurization complete. That coming at 3:44 p.m. Central, 4:44 p.m. Eastern Time. Beam now pressurized, and that brings pretty much the end of step 5 and the end of all of our expansion activities. Jeff Williams will have a few more items on his timeline, and they'll begin to start getting ready for a series of leak checks and other items. So that final pressure, as we can see on the multimeter, 807 millimeters of mercury. And that putting beam inside the range that it was predicted to be in for this final pressurization. Again, the tanks opened up for a period of 10 minutes, all 8 tanks inside of beam releasing their air into the atmosphere. And the module now ready for the next steps, getting it ready about a week from now for that first ingress.
right, Jeff, you have a go for step 7.1 through 7.10. So 7.1 through 7.10.
1 through 7.10.
So for now, Jeff Williams is going to break down that deployment controller since its job is now done. Beam is deployed, expanded, and pressurized. So he'll break down this controller and also get ready for a pressure check and a temperature check. And that'll probably wrap it up for him today as they'll defer some of the other breakdown activities. But that will be it for Jeff Williams and for the teams down here in Mission Control as they did successfully get beam expanded, pressurized today. So a very big milestone, the first successful expansion and pressurization of an expandable habitat, man-rated expandable habitat in space. So a very exciting day. Took a little bit longer than originally planned, but we made up for it in that last stretch there, getting beam successfully deployed. And we'll come with you. We'll come with some a couple of recap numbers in just a few moments as Jeff Williams gets ready to break everything down.
And we're complete through 7.10. Well, actually, 7.10 is in work right now.
We copy. Okay, Jeff, we do have a slightly higher pressure in beam than station. So what we want to do now is actually equalize that, as you might expect. So a couple additional steps for you. We'd like you to uncap the sample port and then open the sample port valve for 10 seconds and then give us a reading. We're looking to get down around 780.
Okay, copy. We're starting at 8:07 right now, so I will open it for 10 seconds, you said?
Affirm, 10 seconds.
It's 8:06 right now.
Copy. And Jeff, we don't have KU right now, just for your essay.
Copy. Pressure stable at 8:06.
And Jeff, can you confirm that you did uncap the sample port?
Affirmative, and we had airflow.
Copy.
And so with that, one more drop of the KU coverage. Get it back for one more look at beam, though. Right now, Jeff Williams just going to equalize the pressure between station and beam right now. But as you can see, the module fully expanded at this point, fully pressurized, and a very successful day today with the expansion of the first man-rated habitat to ever be flown into space, or the first expandable human-rated habitat to ever be flown into space. It was a bit of a longer day than we were anticipating, with the first first introduction of air kicking off at 8:04 a.m. Central. But after a lot of work by the teams down here on the ground and Jeff Williams up in space, we're able to get the module out to its full size now, with all of that manual inflation completing at 3:10 p.m. Central Time, 4:10 p.m. Eastern, followed shortly by the pressurization, the tanks opening at 3:34 and pressurization complete at 3:34, sorry, it started, and then at 3:44 pressurization was complete, and the module now in a stable, fully deployed configuration. This is going to kick off a series of leak checks and other checkouts that will occur over the next week or so, all of that leading up to the first ingress, since the schedule has shifted a little bit and there are other activities that will likely have to move around. We don't have an exact date on when the crew members will first go in now, but we'll be sure to update you on nasa.gov and across all of our social media accounts, as you can follow along and be sure to find out when these crew members will go inside for the very first time. So I want to thank you for following along on this Saturday, dedicating a little bit of your weekend to us as we complete this historic moment. Again, the expansion of Beam, the Bigelow Expandable Activity Module, complete, pressurized, and just a week away or so now from humans going in for the very first time. So thank you for spending a few hours with us this Saturday. Be sure to follow along on social media as we get closer to that first ingress. We'll be sure to provide you updates throughout. For now, though, we are going to go ahead and sign off one final time today. This is Mission Control Houston.
We're 1.5 minutes from a 6-minute.